Welcome to Metaverse Inception. Alab will be your guide today. In this webinar, we're using 3D Max, tyFlow, Unreal Engine 5, Quixel, and you should have an email before this, and I've also put it in the chat with a link to download a PDF that the lab has provided. So as I mentioned, the lab is a current student in our master's degree program, and he's also a computational designer at Moonray PVC, which is a blockchain RPG based RPG game, Metaverse. So Alab is a licensed and practicing architect based in the Philippines. Alab is currently expanding to multiple design disciplines and is currently pursuing advanced design through computational methods. He specializes in organic and biosolid forms using procedural techniques. As a Metaverse designer, he has worked on numerous collections and projects with a wide array of industries. So Alab, if you're here.
Hello, can I be heard?
Yeah, how are you doing?
Doing great.
Yeah.
Thank you for this.
So, yeah, of course. And yeah, I'm gonna be here. I'll be here the whole time. If anything, needs, I'll try to answer questions. And yeah, let's just take it from there, and we'll hand it over to you.
All right.
Oh wait, before you start, I just want to remind everyone, if you have questions, please use the Q&A button. So if you see on your bottom button, Zoom buttons, there's a button that says Q&A. Please ask questions about the webinar there so we can keep track of them, not in the chat. But if you're just talking in the chat, please make sure you switch it to say to everyone, or else you're only writing to me. Okay? Go ahead, Alab.
Thank you. So the first part, I just want to go through what we'll be tackling today so that everyone has an overview. First off, we're going to discuss the preliminaries, which is checking if you guys have everything set up, because some of these technicalities, I even need to have notes for them for myself, because sometimes they're hard to memorize. And so that's for 3ds Max, some tyFlow stuff, Quixel, setting up Quixel and the project. So maybe for 30 minutes, we'll go over those preliminaries, and then creating the character itself for an hour, and integration into Unreal. We have a break at the middle, and then creating the architectural piece, and then building it up on Unreal Engine. So before that, I wanted to share like some of the works in Design Morphine Masters, wherein it actually developed and led to this sort of webinar. So for the first part, we were designing a prosthetic suit for a character, wherein we were trying to explain and design a world that we wanted to create. So this is all about poly modeling, some procedural techniques, some rendering, and sorry. And for the second part, the habitat, which is, in this case, it's on a cliff. So everything was coherent based on a single concept. The third part, which is like a colony, just have to refresh. It's a colony, and it's on a cliff as well. For the fourth part, I'll just share a video. Like, I'll share 2 videos. The first will be a product of the Masters Chapter 4 Kinesis, where we were talking about the transport systems and the vehicles. And for that part, you'll also see the output in Unreal Engine. So it shows what you could do in Unreal Engine with the basically if you just not too much knowledge on it, like just the basics. If you're coming from an architectural background or a design background and you have no experience with Unreal, Unreal is super handy for that. So all right, and the second video I'm going to show you is hopefully something we'd be able to create. Not sure if we'd have time, but basically what we're going to teach here is creating the frames or the sequences for them, but compositing them afterwards might be another task. So this is what we're going to create. Okay. Hi, everyone. I can see some familiar faces and some support from classmates. Thank you for that. By the way, if you guys want to keep along with the tutorial, the webinar, I'd really appreciate it if you'd send screenshot, tag me and Design Morphine as well. And yeah, that would be great. So just an overview. I wanted to show you that when you're downloading Quixel, you might have had Quixel already, but there has been some problems with it actually working out of the box with 3ds Max. That's why I created this PDF so that you'll have a guide in case you're getting lost. You're wondering why doesn't it export. So let's try to open Quixel. See. So first off, when you download Quixel, you'd be asked what plugin or what program you wanted to export to. In that case, you're going to put 3ds Max. Let's see. And then for it to actually work inside 3ds Max, ideally you would want to have this plugin, the Megascans plugin, work with your 3ds Max, so that when you download anything, let's say you download a rock, which we will be getting into later. So check this. Export settings, you have to make sure that the target is at 3ds Max. I highly encourage that you look at the PDF just in case you need to set things up, but hopefully you were already able to. So if that's necessary, I'd have to go back to it and show you guys again. So all you got to do is go to your start menu, type in variables, and then you're gonna click environmental variables. You need this because innately 3ds Max operates on Python 3, and the latest release of Quixel is still on 2, so you'd have to change that. So in your case, if you haven't done it yet, you're gonna have to press new, and whatever was written on the PDF, just input it here. So in this case, copy this one. And then put the variable 2, press OK, and you'd be good. Next time you open 3ds Max, you'd have this Megascans plugin already ready. So just an overview. The common hotkeys I'd be using, I'm not, I didn't make too much custom hotkeys. Just Alt W for maximizing and minimizing the viewport. And when I'm on edit mode, what these numbers are just what I've switched from through vertex mode, poly mode. Let's say, for example, I'll convert this to an editable poly, so you'd see that if you press 1, you're able to use the nodes, the points, the vertices. You press 2, it moves the edges. 3, this only works if you have an open boundary. So if you press 3, it clicks on the boundary itself. 4 for the faces, and 5 for the element. So what I want to show is first try to get you comfy with the Max interface. So what I usually do is I configure the viewport so that it would be easy for me to have the perspective here, and I see the top view, front view, and left. That's how I do it. So again, you have to go to your viewport, configure your viewport, go to your layout, and pick a layout which suits you most. So as for our schedule, 3ds Max first, you have to get that set with Quixel, and you have to make sure that you also have tyFlow. Let me check. And for anyone who hasn't still downloaded tyFlow, I'm going to link it down here. And the thing about tyFlow is there isn't really much out there, because tyFlow can fit so many different needs. It can fit a VFX sort of need, procedural modeling. If you're into architecture, that helps as well. And the way on how to learn this plugin really efficiently is if you go to the tyFlow documentation and just type what you need. Everything is there. And I used to think of this software before I wasn't really as adept in Houdini as I became in the masters. I saw tyFlow as sort of this easier version of Houdini, where everything, all the user interface is much easier. You'd be able to see everything there right away. It's not as technical as Houdini, because, for example, in this case, the words that they use are very much, you can understand them right away. So let's see what we need to tackle next. So the first thing we're actually going to do is we're going to dive into Unreal Engine, and we're going to create your project. So I use early access 2 because first I indicated in the details that I'd be using early access 2, and I've tried using Unreal Engine 5 and Unreal Engine 5 now, the most current one, and it doesn't really work with much of the later plugins and the later add-ons in the marketplace as they do with the early access. So first off, you're gonna want to create your project first. So this is where we're at. We're creating our project, and you need to be in this step as well, because in this project, that's where you're gonna import or export the character from Unreal Engine and bring it into 3ds Max for us to sort of play around with it. So in that case, you're gonna want to choose games and third person, and then you're gonna want to choose a location that works for you. So in this case, put it in a folder that doesn't have too long of a name. And then let's say in this case, let's have Inception. Okay. Let's see. So name your project. And create, make sure that your target platform is desktop, quality is maximums, and turn on starter content for us. Because starter content has some of the materials and shaders already set, and if you're new to Unreal, there's tons of learning things or tons of material that, and samples that they already have that you can just open and learn from. So this is our first step. When you open Unreal Engine, you see this this map, and just an introduction to the user interface of Unreal Engine. If you press Control Space, that is your content browser. This is your folder. This is the folder of your whole Unreal Engine project, and everything you put there is here. So let's try to see the similarities of what we're talking about. So if you have your project folder here in the Explorer, and let's say this is Metaverse Inception, the folder itself, everything that you see on this Explorer is here as well. Sometimes you'd be tempted to import directly or paste directly into this folder, but I highly suggest if you're going to import it, open up the content browser and import the game or import to this folder. So let's see where we're at. So first off, let's set up the project. What's important about to know what to do first is in what we wanted to have a rendering pipeline in the end. So some of the features need to still be enabled in the plugin. So what you're going to want to do is type in. Yeah, I see someone, you ended up downloading the final version. This it's actually okay to have the final version. It's even okay to have Unreal Engine 4.27. But the only difference with it is some of the plugins won't work, but the output will be the same because there's no, I haven't found any plugin that we're going to use in this webinar that won't work on 5, the current 5. So you're going to want to enable movie render queue and enable render passes as well. So it's going to ask you to restart now, but since we still have other things to enable, if you're getting lost, it's in the PDF. I listed everything with regards to the project settings and the plugin settings in the preliminaries part of the PDF. So just in case you haven't as well, Datasmith is a plugin that you also install So this is for making everything easier to export from 3ds Max to Unreal Engine. Although we can go with the traditional method of exporting it as an FBX and bringing it to Unreal Engine, but this makes it easier for someone who doesn't know all of these export settings. Like for example, you're using 3ds Max, or you're using Maya, Cinema 4D, or Rhino, and you have everything set on V-Ray already. It's gonna export that. It's gonna export that on into Unreal Engine as how you did it, and it's gonna be closely related to that. So if you see here, just type Unreal Engine Datasmith. And then as you see, it's a pipeline integration so that you just have an easy exporting to Unreal Engine, and all your settings, all your V-Ray settings, all your shaders will be enabled. So if you click get the plugin, there's an exporter for a ton of software that you're using in case you're not using 3ds Max. So that's that. I'm just gonna send it over here in case anyone hasn't downloaded it yet. So back to our project, you're gonna wanna import Datasmith content, Datasmith FBX importer, Datasmith importer, and that's it. So after this, you can restart it now. So it's gonna be a minute or to a few seconds, and you have it enabled now. So the way to move around this is like a normal game, WASD, and then hold right click to move around. It's just as easy as that. So in this case, we have this character, and our goal is in the end to have a character that we designed, we modeled, and to have custom shaders to walk around in the same way. So again, to recap, we have control spacebar to open the content browser. That's where you'll see all the files. Before I get into exporting the geometry itself, I'll just hit play here. When you hit play, you're actually taken into the character itself, and you're able to move it. So we want later on that we create the character that we're able to move around. So first off, to find the geometry of the mannequin itself, we go to mannequin under content and go to character and then mesh. So there's the male mannequin and the female mannequin. So with the example that I created, I used the female mannequin this time. Let's use the male one. So right click on it and then asset actions, and then export. So export it. It doesn't have to be in the same location of your Unreal project, but your Unreal project has to be in some sort of asset location. So in my case, this is the workshops folder. You have a folder structure that has your project files here. So project file here, this is your Unreal project folder. Go up a bit. Ideally you have an exports folder where you're gonna export everything. So let's name this mannequin UE5. And then these settings should be okay. Export. So let's check. should be here. So you have the male one here. So to start off, we're gonna want a blank slate, a clean project. Right off the bat, we're gonna save it. Save it in the working folders. Let's name it Metaverse Inception character. And then what I usually do with my interface is, if anyone has used Maya, they have the outliner here at the left part. So you're able to see all of your objects. So for example, you create a box, it's seen here. And I wanted to actually touch on this panel a bit because this panel is your most used panel. It's at the right. So this is where you'd be able to create. And in create, there are standard primitives. That's where the box is. And the splines are here. So if in any case you want to create splines, lights are in this tab. Cameras here. And the others that I probably won't be discussing can be learned in sort of a basic tutorial of 3ds Max. But in this case, you can be in this workshop or webinar with just actually nothing, not much knowledge about 3ds Max. I'll be helping you throughout. Hopefully, if anyone has questions, just type it in the chat, and I'll be there to help. So in this part is where this is the modify tab. So if you click any of your objects in the scene, you'll see the attributes here, all the parameters that you need to change. When you're working on it, you're usually working on this side. Hierarchy wouldn't be important until later on. So we'll only be focusing on the create tab and the modify tab. So let's go ahead and import. Let's import the character. So we had it in the exports. Click from file type 3ds Max to all files, so you see everything. And then import the mannequin itself. Okay. So the default settings will be good. It's pretty low poly. See? So I'm deleting the other stuff here, which aren't too necessary. So when you import it, you'd see there's a hierarchy. Later on, this is important because this hierarchy is important because when you export the character, for it to actually use the skeleton of Unreal, so that you'll be able to access the default movement and the default animations, you'd have to have it the same bone structure. So this root is what the bone structure is. In this root, you'd see how it's organized. This is the default Unreal hierarchy of bones, wherein you have the feet, the spine. Let's turn this off. And everything in this is in this sort of hierarchy. And it's important to have the same organization of hierarchy so that when you import it, it's not it doesn't mess up. So what I want to point out is for all Unreal skeletons, it has to be the root bone has to be the top bone. So in this case, in this hierarchy, it's not. So what you want to do is unlink it so that the root is at the top. So after that, let's duplicate this so that we only have right click clone so that we only have a mesh, because we don't want to mess up the bones of the original one, because we're going to use that later on to rig. So let's see. Has anybody tried to download this same model, and is it coming out the same, this tessellated way? If anybody is having a model that looks more detailed, or just type there, because ideally it would be a higher definition model. So let's see, let's try to export it again. So because there seems to be some problem with the LOD, it's really tessellated. So probably in this case, I'd remove the skeleton, and once remove the skeleton, and let's start from a more high res. So I'll import the female mannequin. Let's see how it works. So this one has a higher level of detail. I'll send it in the chat if anyone has a problem with it, with importing. So I sent the FBX. So first off, again, remove the root bone, unlink the root bone from this so that the root is at the top. And then you have this mesh. Let's duplicate the mesh so that we don't, when we're working with it, we don't mess up the original one. So clone, and it must be a copy. And we don't want this this mesh to be under this hierarchy, so we're going to unlink this one. So to be organized, let's rename this in the modify panel. Base female mesh. And in 3ds Max, once it says skin is the technical term for to say that it's actually already rigged to the bones. So we want a file that's just a mesh without bones. So we can either remove this or convert it to an editable poly. So this is the base mesh. And for the time being, let's select all of the bones, select right click, select child nodes, and then turn it off. Same goes with the original mesh. So in the scene, we'd only have one. And then let's go on to the procedural techniques of how to create this character. So first off, create a tyFlow node. So the way to do that is go to the create panel. You have to be in this plus sign. And in the geometry primitives tab, click on tyFlow, drag it outward. And then once you go to the modified panel, to be able to actually see the tyFlow, you have to click on it, modify panel, open the editor. So first thing you're going to want to do is you're going to want to bring into tyFlow the mesh itself, and we want to make it a VDB. So that you'll be able to smoothen out all of these details and create something else out of it. So birth VDB. Make sure it's not too big, not too small. This is actually in usual person scale already. So like probably 1.7, 1.8 meters tall. So the good thing about Max is everything, you can set it to have really accurate measurements, which makes it ideal for like construction things, architecture, detailed drawings, and so forth. So to bring it in, we have to have this node object to SDF. So we're bringing in this object. So click on female base mesh. And once you've had that, you can turn this off now. You can turn off the base mesh, original base mesh already. So you have this character with this amount of tessellations. Later on, we'd still find out if we actually need higher res or lower res. So if you've gone to this point, congrats, because at least you have a different mannequin now, and you're at least a step closer to creating your own. So I want to show you how you could actually create volumes using textures. And the way to do that is hit M to bring out the materials panel. So again, M for the materials panel, or material editor, if you can't remember the hotkey, everything is pretty much here. Here in this area, it says material editor, click on material editor. And then let's say we want to have a volume like, let's see. Let's look at initially what we had though. So this was a model that was created only for rendering. It's too high density to be used in Unreal. So I'm going to show another one. This is what we can create, which is a little bit less poly. But in this case, we might try different techniques. I'm going to show you different techniques on how to create it. So first part, the volume. So open your materials editor and then right click. When you right click, it will show the different options that you can choose. So in this case, right click on maps, general, and you could see a lot of different options. Let's say noise, you have a noise map here. You have cellular, which we'll also use later on. So noise map. And we want to be able to process that noise. So to show as a VDB, because VDB is technically many different voxels spaced together that build up that build up the whole volume. And we want a noise to use a noise to either erase or show some of those voxels. So first thing, you go to VDB modify. You want to modify the VDB with the different options that are set here. So we're gonna try set as a vector operation, and then surface text map. Let's try. And you have to pick the object. Let's pick the base mesh as the reference object, and then specify the text map that we're going to use. In this case, drag on the noise map onto this text map section. Let's see. Working. Let's see. Might be too small though. Let's see. 100. Let's try multiply. Might have forgotten a step. Multiply. Oh, what we have to do, by the way, is right now it's operating on an SDF, so it's just operating on the surface. You want it to work on a volume, so we have to convert the VDB from that surface to the density. So it goes VDB convert, you place VDB convert SDF to density, and then you place another VDB modify and set it to work on the density. And for that to work, you have to have the input VDB as from SDF to density. In that case, we already see something changing. So to be able to make this have use for this noise map, it's actually telling the VDB that where the white areas are, where the volume would appear, and the black areas would be lessened. So first off, we're gonna change the scale to, let's try 30. And then the high and low, since right now you only see gray areas, we have to raise the low, which is the black area, so that we'll see more black. And the high areas, bring it down, C8. So modify the density. Again, it has to be minimum text map, and then minimum scalar operation, and then the input scalar is a text map. So pick the object again, base mesh, and then specify the texture. See if it works. Right now, it's super sparse, so you want to try to have a smaller scale. So a smaller size. So we see in this character, it's really it's too it's not dense enough. So we might want to bring the voxel size down to like 6 to have more detail. And change the, you can play with the noise map however you want. You can try it to be fractal or turbulence. Turbulence is a different way, but basically whatever map you choose, it's going to use that map as an input to show where the volume is and show where the volume isn't. So what I like doing is going to fractal, because in fractal, the more levels you have, the more noisy your noise map gets, and the less levels you have, the cleaner it gets. So I pressed I made the levels 1 to have it more definite and to have more definition and smoothness. So probably for this type of for this model, it's still too dense, so let's try going down. And you can drag it down here so that you can see how much of it is seen. Probably have it 6. So what we're trying to build is a multi-skin character where you have the body itself and you have the internal organs and then a sort of skin. So this is one method to create a volume. This method will also use later on to create the architecture itself. So next, let's try. We can either have this if you appreciate this already, or let's say you make it smaller. You can create a new tyFlow and do the same process and try another map. In my case, let's try using another map. So the cellular map. So we go back to the VDB modify and find the input where we actually put the text map, and then drag the cellular onto this one. So let's turn off the display selected. So the cellular map, if you enlarge it, it's much like little dots. So I'll increase the size so that we can understand it more. So if you look at this map itself, you pretty much understand what will happen right away. That's the key to creating more iterations yourself later on. So you see that there are black areas, there are gray areas as well, and there are white areas, and it's sort of fuzzy, so things will actually come out as a tiny spheres. In this map, you have several options. You can either make it circular or chips. Chips is like a Voronoi if you want to have that. That's another method that we can use later on. Pretty much right now it's pretty fragmented, but later on we'll be able to clean that. So what I like doing is having this circular map, maybe making it a bit smaller, and you see the spheres are starting to appear. And ideally, we want some separation so that we'll have a differentiation of the volume. So the way to do that is you're able to actually control the color of each part of the map here. So let's make it larger again so that you'll understand the map. So when you adjust it here, it actually reflects right away. So we see that in this map, things are sticking together too much. And what your input here actually goes here right away. So white is at the middle, gray is at the outer corners of the cellular map, and black is at the gaps. So if you would want to, let's say, have more of a gap, let's try turning this black, and immediately you'd see that it actually has these gaps already. So a bit there, and this middle area is actually referring to this middle color. Where is it located, or how deep it is? So if you try midpoint for, it actually makes it closer to the center. The smaller you get, the closer it is to the center. And what that does, it creates more gaps. So let's try bringing it back to a scale. So if you see, once when we put the scale smaller, you actually see the spheres already. So what we can do though is we can have a sphere like this, or if you want just the outer rings, you can make this black so that nothing is seen, and then the outer is white. Let's see how that looks, or the middle. So in this case, it's like a subtraction, an inversion, where the middle areas of the sphere are not seen, and the outer ones are. So let's try to put that at a higher number, move the middle color further up. So once you move it up, you actually see that it's getting more spaces from the last color. So let's try putting up at 0.7 or 0.8. let's try for 2 different tyFlows so that we have the inner and outer circles. So let's create a new tyFlow, either that or we go on tyFlow 1 and duplicate that. So you want it as a copy. And then tyFlow, you also want to duplicate your map and drag it down so that you see you can have another map on this inner portion. And then you plug it here on the surface text map. So in this map, we're gonna have the balls in the middle. So bring this to white and then bring this to black. So you see right away, you can have a pattern on your character or however you're creating it. So we can actually go ahead and go to our tyFlow and change here whatever mesh we want. So if we wanted to make this smoother, what I'm going to do is disable first all the other tyFlows and then go back to this base mesh. And then create a new one. So we're going to make this, turn this into a VDB again. Birth VDB. VDB to object to STF. And you pick this one out. So the way we could do it is we can first have a sort of a low res model. Let's say 15, let's try 15. At 15, it's getting a little bit smoother. We can try 10 again so that the fingers aren't too much affected. And then you go click on the tyFlow itself and you go to the drop down area of the modify panel and then you click on tyRelax. So this tyRelax generally relaxes all the vertices so that things can be adjusted. So tyRelax, you click up the iterations and there it is. You're gonna get a smoother, more relaxed mesh. So I think this would be better to work with rather than the base mesh, which has segments. So let's try to turn this tyFlow 4 into a sort of base mesh. So what we're gonna want to do is convert it to an editable poly, so it becomes a mesh in itself, and it sort of bakes from tyFlow. So base mesh. And then what we could do is go back to tyFlow 1, open the editor. And then go enable this again and remove the female base mesh and click on base mesh 2. So we could a ways that we could see it better rather than this yellow object. We can create materials. So PBR material, metal roughness. This one works better with Unreal, but we won't be using these materials for Unreal. We will be creating our materials in Unreal. So let's just have a color for it. Let's have our base mesh blue, maybe gray, dark gray. You can turn that off now for the first tyFlow so that you'll see the difference. Drag on Shift so that you duplicate your material Pick a color for it, whatever you like. Assign it to it. So click on tyFlow 1. Let's name tyFlow 1 base negative. Since that base negative is sort of the cavity of our character. And then open the editor, go to tyFlow 3. Is it 3? Yeah. 3, which actually has the positive, turn it on. And you'd see that there's sort of a differentiation already. So for tyFlow 3, let's rename that to is positive. Drag again your material. Let's try to make this a little bit goofy and contrasting, maybe pink. And then set your base positive to that. So we have two-tone. Only thing left to do is to replace the base mesh of this negative, because it's still using the segmented one from Unreal. Base positive, I mean. Go back to your object to STF, remove the original one, and then click on base mesh 2. And there we have like a smoother version. So since we're gonna have multiple layers, I'm gonna leave it to you to decide which ones to include once we rig this and then turn it over. So if we just have these, you won't be able to see the vein. So by the way, I'm gonna go ahead, go back to this, and maybe it's too thin. So maybe it's too thin around the shoulders, maybe not. I'd leave that to you to decide. You can actually make it larger this way. So type on displace so that you can see displace. And use the existing mapping, whatever it used before that, so that we don't disturb it, and then have a strength. Let's see if this works well. Probably not. I'll show you another one. So volume select to make sure, click on the volume select modifier to make sure that everything is selected, all the faces. Click on this face. So it selects all the faces, and then go to push. And then you increase the value so that you're able to make your character larger if it has any problems with the VDB or not. So let's turn this off again. If you see somehow it gained some weight, I think. In this model, we'll probably turn off the base positive so that we'll be able to see the veins. And a quick edit on how to make it smoother. Let's do tie relax again. So turn off the display for the edges so that you'll see it better, the geometry, and raise the iterations. And you can do this until you're satisfied with the shape itself. So as you see, it's some sort of hollow volume. What we can do next is the veins. So for the veins, it's a different it's a different approach, but it's in tyFlow. So you're gonna want to bring up your birth voxels. birth voxels node. So in tyFlow, all of the nodes that you can choose are actually here. If anybody gets lost, you can just press tab and then type. Or if in any case you wanna learn any of the nodes and what they do, go to the tyFlow documentation, and the modifiers are here, particles, operators. So what you see here are called operators. If you want to learn any of them, go to the tyFlow documentation and just click anyone, and they really explain what to do. But in this webinar, I'd only be showing you a few. So to understand what's going to happen, to understand the concept of what we're going to do is we're going to create some sort of veins design inside the volume itself. And to do that, these veins actually have to have a target in space to go to. You have a start, you're going to have a starting point, and the veins will actually branch out to those starting points. So in that case, birth voxels, and then click on base mesh 2. You're going to see right away that you're going to have voxels in space. So it's pretty sparse. We're gonna want to make it a little bit more dense. So let's try 20. And then at 20, you start seeing the voxels inside. Let's try first if with these voxels inside, we see what we want already. So birth voxels, you're gonna want to put another node, which is custom properties, which is in this teal colored tab. So we want the dots to be a certain value so that we can set the target of the growth later on for them. So custom properties, drag that into this one. And then you're gonna want to set it the custom float into a value. So this is important because you're gonna set the target name later on. So let's say this channel target would be growth target. Growth. So in the same window, let's bring out another node. A birth node. In this node, we're gonna identify where we want to start, where we will start the growth. So let's imagine we want to start the growth at the head, or maybe at the heart, or let's say at the head. So let's go to the create panel so that we're creating a target volume to show where we're originating the growth. So the sphere, let's just make it symmetrical. In this case, this area is where you set the transforms, the numbers, or in this case, this is the transforms of the location of it in space. So let's set it all at 0 first, so that things are in center. This is important because we're rigging a sort of symmetric character, and the bones would be originated at 0. So drag that up, and in this layout, you'd see where it's actually beneficial to have this layout, to have this tree. So you want to have it right around the head, so you can drag it here, and then before after, you can bring it to the head. And then so you have the W, E, and R keys for scale, for move, W for move, E for rotate, and R for scale. I think for most software or other software, it's also the same. So let's go ahead, press R to bring out the scale gizmo, bring it closer, make it smaller. And then as you see in this area, we have a volume here where we could start the growth. So birth object, this node is just telling you how many particles you want to birth. So as I discussed this with you, you quickly realize that it's very intuitive, how the user interface of tyFlow is set. So this is talking about in which part of the timeline or seconds or frames you want it to birth. So if you want to see your current timeline, it's from 0 to 100. In this case, we want all the particles to birth at start. So start at 0, end at 0. And then the total, this is the total number of particles. In a growth system, you want just to limit it to maybe 5 for it to be pretty sparse. And then you want to align your particles to this object. So position object, bring it here, and position it to the sphere we created earlier. So sphere 1. If you don't see the dots yet, let's try clicking the display into sprites. It's only 5. So if you click here, this is the isolate selection. We want to just see the sphere or the tyFlow if it's appearing. So click on that. You can actually see that some of the particles we created are sticking to the sphere already. So you can work with this first, turn off the sphere. The particles are here. And then we want a growth system. So in the screen tab, drag on a growth system, a growth operator. And right away you see it's actually spreading right away without any parameters set. So let's display it back to pixels again. And for you to see sort of veins like growth on it, you have to go to this orange tab, drag in the spline paths, and then click the mode from trajectories to parent, because trajectories will actually map out the trajectory of your particles. If you have moving particles, it will make particle trails. But in this case, we want it to connect to each other. So it's parent and uncheck process at end of time step. Create new, and you see right away the spline you created is at the left side. And you could click this later on if you want to manipulate it. So if you scrub through the timeline, you can see right away it grows outward. It's not controlled in any way. But since we want to control it, we want to set those target points. We go to the growth algorithm and click on space colonization. And then we have to set a target particle. Let's try enable filtering by custom float. And then this is the value that we set earlier, the growth target. Click that, see if it works. Actually, it's not expansion particles. It has to be set target to seed particle. So let's click on growth target. Let's see if it works. It's actually working, but it's too sparse. So the reason it's getting removed there is this is the kill distance. This is the expansion distance. Kill distance actually removes the other target particles nearby. So we don't want much of that. Let's try setting it at 0. Right away, you see from the head where we set it at, it grows outward. And it's really easy to create this. Goes outward right away. So to be able to control that, maybe you'd want less of an expansion distance. It's going to be more detailed. Or maybe let's just stick to 100 because that seems fine. We might have too dense of a mesh later on. So to be able to start seeing the volume of this and how it actually looks, we're going to go ahead and click the tie splines. Go to tie spline measure. turn it on. So by default, a tySpline has a tySpline measure so that you actually see the volume of it. So turn that off first. Go to tySplines, and first thing you want to do is weld the bindings so that they won't be separated like this, because each node is actually separate. So let's try welding the bindings. Right away, they're smoothed out. Let's try welding the knots. Let's not weld the knots so that because they have several sort of branching. Or let's see. I think it's better to weld the knots. And then in tySplines, to have that, to achieve that veiny look, the tySpline measure actually, you can actually control how the tube is extruded. So in this case, let's try curve. Right away, you see it's sort of funky. You're not able to control the length of it as much, but you actually do have more control. So the idea is of this spine system is the longer ones are thicker and the smaller ones are thinner. So let's try multiply radius by length. So in that case, it's saying you have a threshold. At 500, it starts making it. If it's 500 or less, it's smaller. Let's see. Let's put the minimum higher. Reducing that. You see, once we reduce the length threshold, the smaller ones become bigger. And then let's, because these parts are kind of too tiny, let's adjust the curve. So let's try adjusting it this way. Now you actually see it has more volume in it. Maybe let's go back and make it a little bit more detailed than before. Let's try 50. If it's too dense, let's make it the voxel size 30. Let's try that. So if you press 7, 7 actually brings up the polygon count of your scene. It's important to have it, to keep it low, because for game engines, it needs to be a little bit lower. So in our case, it's pretty dense. So let's try bringing it down. This one is super dense. So let's go to tySplines, turn this off first, and then click on the normalized spline. Look for the normalized spline modifier. And we're trying to resample the nodes and make them like a longer distance before they have try to make them less dense. So by the way, if any of you have any questions or you're having trouble keeping up, feel free to just hit me up on the chat. I'm always looking anyway. Maybe once in a while, put in a chat message or something. At least I know you're there. So let's remove max knots. Let's try that. Probably take some time. So we want a segment count, segment length to be, let's try, this is usually what I use to have a measurement. If you want them to have sort of this far apart from each other, it says here the radius is 15. Let's try a distance of 15 from each other so that they're not too far apart. Let's try 15. Yeah. Hi, Oleg. So let's try turning on the tySpline measure. Turn on linear segments. And right away, we have so much less polygons to deal with. I think this would be okay. pretty fuzzy here. Maybe up to you if you'd use this, but we're gonna have other techniques as well. So let's bring that back to 20. So we have a little more definition there. So I'll make this a bit quicker so that we can bring this in Unreal. We still have a skin to create. So let's leave this at that and then create a new tyFlow. And then we're gonna wanna bring in again the mesh that we created earlier, which is base mesh 2. So we're using this base mesh to have some sort of like fields around it. So in this area of the particle event, we're trying to create forces first. We're going to create noise field forces to generate our particle fields later on. So remove the VDB to mesh. Actually, let's just work with this first. So click on tyFlow 3. And then VDB display. So you'd actually see, hopefully, what's going on. So VDB modify, so that like we discussed earlier, we're gonna try to manipulate the VDB. Turn off VDB display, and what VDB modify does is right now is it's bringing all the points outward because the normals are outward. We want to have some sort of field around it so that we can control the particles later on. So for me, it's set the vector operation, set it here, and then have it as a noise 3D and curl. Right away, you see something sort of funky happening here. It's sort of a noise right now, but it's the same. It's the same way how we created the initial VDB with the maps. It's doing the same thing. And let's try to set the birth particles around it so you actually see what's happening. So again, start and end at 0. Let's try 1000 particles. And then have it start. Let's have it start on the mesh itself. So how we do that is position object. Click on the base mesh. So now it's positioned all over the base mesh. And then we want to bind it to the surface so that it doesn't move away too far. Pick again the base mesh tool. Lock the surface and snap the surface and turn off the friction. And then the force we created earlier, we're gonna reference it here. So let's do VDB force. Set the VDB force to replace and then replace again. And let's see what it does. Turn off the VDB display. So you see it now, it's actually moving. But to see it better, let's go to spline paths. This is the thing I discussed earlier with parent and trajectory. We want to create those trajectory lines with the splines. So we created the tie splines. It appeared here. Tie splines 2. Let's see how it fares. So basically, what it's doing is the force field we generated earlier with the noise, 3D noise, it's actually driving the particle movement, and we're tracking the particle movement, and we're creating lines out of those. So again, time spline measure is there by default. Shading. Maybe it's too dense, so have the noise scale a little bit bigger. So smaller numbers mean bigger. Let's try 0.05. It's a little bit bigger. 0.808. See. Let's change this color so that you see it better. Orange. And let's turn the other volumes off so that you just see that. It's negative. Yeah. So you want to have it symmetric, so kind of looks a little bit better. So let's try putting a symmetry node on modifier and have it mirror at the x-axis. So right away you see it's symmetric. You can see the face from there already. And then we're gonna want to manipulate again the spline so that it's less dense. So turn on the shading so that we actually see the density. Let's just copy in the tySpline's normalized spline and paste it here. It'll take some time to load. So see. Now it's loaded, normalized spline. And then, so it's a little bit less poly than before. You see it's more workable now. So we're gonna wanna tweak the spline length again so that it looks a little bit better. Let's see. So with the tySpline measure, we're gonna try to make it a little bit smaller, maybe. Multiply by radius length so that they're actually different. Others are different. Let's put this 2.3. Make the threshold smaller. Some are small, some are huge. And then maybe we'd want to have it like this, sharp at the edges. And then click on symmetrical taper to have things sort of symmetrical at the end. Yeah. Like this. Turn on symmetry to check if you like what you see. If you don't, you can try to play with the other options, play with the scale and phase. So let's try doing that. Let's bring it up a bit. See if it changes. Let's wait for it to load. Yeah, actually, ideally, turn these off first so that the processes don't run into one another. So try to change the face. Try to get what you want. And then click on normalize spline. Wait for it to process. Spline measure and then symmetry. So you have it semi-symmetrical already. For me, I saw that the other side is actually looking better. So let's flip it to the other side. Let's have this. And then you can actually manipulate the spline. So what I like doing is putting the squash up so that it's like sort of leaf-like, so that it's elongated. So you squash it a little bit more, let's say 20, it's too much. And then rotate it so that it actually faces outward a bit. And turn on the symmetry again. So let's see what we got. Up to you later on if you want to use this. But for me, I'll use the outer part and the veins. There's the veins. Turn on the veins. So we want to sort of bake the spline so that they don't move when we move the slider. So before doing that, you copy all of the modifiers that you did to the tie splines. Go to the bottommost, click on tools and extract the splines. That way you have splines that don't move. Once you, right, so that you don't have too many processes on top of one another. I actually moved it, which is wrong, while it was still not baked. So the processes are stacked up onto one another. Let's wait if it actually moves. So good thing it didn't crash. So you can turn off this tyFlow, so that the processes aren't stacked up. Actually, it's tyFlow 3, not 2. Remove that, and whatever you copied earlier from tie splines 2, we copy this, and then paste it here. Okay. And then we only have these veins that are still sort of turned on earlier. So let's try to move it. It's a bit heavy. Let's try to make it a little less dense. So go back to tyFlow 2, make it 30. And then turn off the normalized splines, because normalized splines is really heavy. Bring it up until you're satisfied with how much growth is in your character. So let's see, we have that. And then we bake it. Extract splines here at the tools, extract splines, so that we can turn off the processes. Turn it off here. Copy and paste it onto tie splines. Let's wait for that to load. So we're going to use two of these volumes to turn into a character. So let's rename them. Let's turn this into base inner. And this one, base outer. So you can customize however it looks later on. But for this case, so that we can move forward, we're gonna stop with that and move on with the rigging. So base inner and base outer, clone them so that at least you have a copy of whatever you did. So let's clone them. It's just processing. See, so it's out now. Right click and then convert to editable poly. So that there are no more processes. It's actually just a mesh now. So we want to have them have two different materials at least when you're. Wait, let's remove the funky bits that we don't want. Say this one. Go to editable poly, click on the elements, and then just maybe delete whatever sticks out there. We can fix for that to happen in the growth. But since we're tackling a lot, we're just doing it this way. We're tackling a lot today. So go to the materials panel, click on M, and at least set them both as different materials. Any material you wish, because we're going to create our own materials later on in Unreal. Set them as such. And then we're going to have them in one mesh, because when we're rigging, we want them both in one mesh. So let's check first if they're too dense. This one is okay. Go to editable poly and attach. Attach this vein that you create inside. So now you have it all in one mesh. What's left to do is to rig it and bring it to Unreal. So let's see our rigged mesh. Our original one, SK mannequin female. So to check if this is rigged, you go on and select all of the bones, select child nodes, and then turn them on. Try to move one of the bones. In this case, let's try to move spine 3, or spine 1. Let's try and rotate it by clicking E on your keyboard to bring out the rotate gizmo and then try to rotate it. So if you see, the original one is actually moving. So it's probably rigged correctly. At least it was, because it's from Unreal. So what we're going to want to do is transfer the rigging or the skinning of this mannequin onto our newly created one. So for it not to get too busy again, we're going to select the root and then select child nodes, turn it off. So before anything, you should click on save so that if things crash, it'll be safe. So go on to the skin wrap modifier, which is sort of 3ds Max's auto rigging and skinning tool. And then first you're gonna want to double check onto these parameters, because once you click any of the meshes, they start computing already. So click on weight all points and then add. Let's try to add SK mannequin female. So it's here, it's computing. Let's just wait for that. Okay, it's sort of done. And then you want to click here to convert the skin. So you can actually already check if it works. So if you bend it over like that, it's actually rigged pretty okay. So that's how Max is able to do auto rig with a pretty dense mesh. And not have any problem with it. So just like that, you have a rigged model already. So let's just name this base character because we're set with this already. Base character. Save it. And let's export this. So export selected. Go to workshop, your exports area. So in the exports, maybe name it base character to UE. Save it. Let's see if the default, see, it's probably the default way of exporting it. Shouldn't have too much problems about it. Click OK. Now let's see if it actually works in Unreal. Let's remove these walls. So click on, well, it's probably these. So click on all of the walls and hit delete. And control space to bring up your content browser. Go to geometry, meshes. Or actually mannequin and character. You want to keep everything organized because in a larger scale project, everybody's gonna be putting in files there, and your file sizes and your folders will be super messed up. So you want to keep your characters where the characters are. You want to have your level materials if you have trees in another folder. In this case, just the character, have the mesh here, and then let's try to just drag and drop. So from your exports, remember we had this base character to UE. It's a bit dense. Let's see if it works. Let's see. So you're met with these options right away. Skeletal mesh, import mesh. Check these. And you already have a skeleton here, UE4, mannequin skeleton. Okay, don't import animations. We don't have any of those. And do not import any materials because we'd be creating all of our own materials here. Import all. Yeah. We'll have the break right after this importing. And yeah. So the break is supposed to be scheduled like right around halfway after we create the character before we actually move into the architecture itself. So let's see first if this will work. Probably a bit slow because it's quite a bit dense, I think. Just wait for it to load. Okay, let's see if it worked. Let's see, let's try. Let's try to put it here though. And let's see if it actually moves with the animations of Unreal. So you click on this character that you just dragged in and use an animation asset, and let's try it if it works with the idol. Actually does. So for us to use our mesh for our character, what we can do is this is the third person character. We go to content, type in VB third person character, and then this is the blueprint for the character. In this case, this visual scripting for the behavior of the character. We just want to click on the mesh itself. This is the mesh of your character. This is the camera where it's pointed. Later on, if you want to change the camera and how you are able to use it, you can do so. And go to skeletal mesh and just change the mesh to the whatever you imported. So right off, you're able to use it now. Yeah, I'm just seeing it now. The rig part in Max was easy because the you're using how Unreal rigged their mannequin, their default mannequin. So this is easy if you have rigged the characters or models already. You just slap it on there and it just sort of copies it. But you're gonna have to want a certain level of proximity to the original mesh for it to work. Yeah. So, Michaela, I imported the model you sent in the chat but did not appear in Unreal. Just the scene. So, the imported model that I sent on the chat is actually for 3ds Max, for you to import it into 3ds Max. And whatever steps that we followed, we're going to do that. And what we exported from Max, which is another FBX, this base character TUE, is what we drag into Max. It's what we drag into this geometry character meshes, if you will, here. I hope that answers it. You're supposed to export from Max to Unreal, not the one I sent. So yes, it looks like it's working here, and hit save. And then let's see, it actually updated already here. So if you press play, you're actually already using the character we created. Pretty neat. You don't have to go to Mixamo because you already have a rigged Unreal character that's already set for the animations and movement for Unreal. So in that case, we can delete this sort of dummy we created. Press delete. And a few more minutes we're just gonna create the shaders and materials for this, then we can take a break. So if you look at it in your content browser, it's the pink one, it says skeletal mesh. Double click it to bring it up so that we can actually edit it. So you see, we created two materials for it, so it's appearing as two material slots here. If you click on highlight, you see only this one material highlights the exterior part, and the internal part, the veins, is what we're having in the inside. So go to your folders, close everything, go to content, wait, engine, content, content, and then you're gonna want to create a new folder at the content browser to, let's say for this, actually not. Let's create it in the mannequin area. Mannequin character and then materials, because these are the base materials of the mannequin that we created early on. Then create material. So there's a new material here. Click on it so that it actually reflects. You can edit it. And with this new material, let's try on applying it to here first. Let's change it. Change the name to M for material underscore body inner. So body inner, go to your character. Let's have it as the internal material. Body inner. Let's see. So since we don't have any edits, it's actually just black now. So we're gonna create a simple emissive material, just like how we did here. So like in most, oh, hold on. I chose the third person. Character isn't appearing in Unreal. Were you able to import properly the character into the content browser? Maj Tamade. Okay, so for you to actually see the character, third person preset. So when you created the project, there's no character, there's no default character in the screen itself. It's supposed to have it when you create third person map or the third person preset, you would have the default character here. And that's what you export to Max and process and import back to Unreal. You can't select the basic character. You select it by going to the content browser, clicking on mannequin character, and mesh. Select it here through this SK mannequin. Right click, asset actions, and then export. So that's what we did with the base mesh, exported it into an FBX. And if you want to edit again the player start capsule, third person character, you can click on the capsule itself. Or in case it's this one, right click and then browse to asset. It will show you right away where it is. So you see it. And then you double click it to bring it up later. And then that's where you change the mesh. I hope that solves it a bit. In the meantime, let's continue on trying to make the emissive material. So to make the emissive material, this is the basic material. It's sort of the same in most shaders and material, where you have the base color, metallics, specular, roughness, and emissive color. So first off, let's set the emissive color. In this case, we wanted to, let's make it pink, light pink. See if it works. Actually works here. Save it. And then it's a bit glowing, but it's not glowing enough as we wanted. So we want to have a multiplier to make it stronger. So Press tab, put multiply. Have the color be multiplied to a certain number. In this case, right click and put or click one, hold one, and then left click so that you have this single value constant that you can put. So again, it's hold one and then left click. So have the value, let's say at 15, plug it into the multiply. So it multiplies the intensity, and then go to bring it to emissive color. Right away, you see it's glowing a bit more. Let's check it. Up to you if that's your taste. You can change it to another color, change it to another intensity. In the example I showed, it was actually sort of animated. So the way to animate it is you make it fluctuate. Let's try. So maybe just follow these steps. Go to the sine curve. And then, let's see. Sine curve. And then, but I just follow this. I won't be able to explain the reason on as much on how this works. But I also learned it. So press add addition. Add. Have it at 0.5. And then, oh, actually divide first. Divide it by 2 and add 0.5. And then you want a linear interpolate node. To have this as an alpha. And then you want it to fluctuate from pink to black, because black is the weaker one. Black shows that there's no emissivity at all. So let's see first. Actually, it's having an error because you need it. Let me check. Where did it? See. Not working yet. In this case, it might be difficult to explain this. So we'll just have it first as a basic non-moving, non-animated emissive map. We'll have an animated shader later on, like how I showed with the architecture itself. So later we'll be having this wherein this map is moving. So to make it a bit quicker, let's settle with pink for now. Make it a bit less, make it 10. Save it. Let's close that. And then let's have a shader for the outer body. So control space again to bring it up. Go to materials, material layers. Let's have another material here. Right click material, M body outer. Double click on it. And then have your, what you can actually do is, while this body outer is selected, you press this button, so all of it gets used. I mean, whatever is selected gets used onto the slot. So right now it's still black because we haven't edited it. The author. And then we wanted to create a sort of gradient look between them. So let's see, we want to plug it into a base color. So texture coordinates. This brings on the UVs of whatever you had. And then linear gradient. In this case, we wanted vertical because the map of the sort of fins are vertical. And you want a linear interpolate because you want to use two colors, A and B. Have the V plug into alpha. And whatever colors you choose, let's say, let's try orange and sky blue first. So while holding 3, press left click again, in case. So it's 3 left click to bring in a 3 parameter color or 3 parameter value or a vector. So if you press 1 left click, it's going to be 1. So again, hold 1 left click for a constant, for a scalar, and then 3 left click for a vector or 3 values. Let's set this to teal. Maybe that would do. And then go to base color, plug it onto base color. Let's see if that works. Back to your character, it actually does work. I leave it up to you to choose the colors for that. But let's put a little bit more values into your shader. So metallic, the whiter it is, the more metallic it is. So let's try to make it white. In this case, it's changing a bit. Your roughness, how rough it is. So the blacker it is, the less rough or glossy. Maybe that's fine. Maybe reduce the metallic a bit so that you'll see the color itself. Or why not let's change this into 3 colors. So hit on tab and type lerp. There's a node called lerp 3 color here. Let's try to plug this in here and have a third color. Let's turn this into, let's try this. And the same linear gradient you have, plug it into the alpha and then the base color. Let's see how that works. Sort of does. You have it colored at the ends pink and orange, how we set it. So again, I'll leave that up to you to tweak later on how you want your character. And let's save this first. Save all of it. Save all. So all of your assets that you've been editing are saved. And let's see in this map, we actually already have our character. Hit on play. And there you have it. Now, we've gone to creating, importing the base Unreal character to 3ds Max. We processed it and brought it back rigged. And now you're able to move around with your character, jump. And that's it for the characters, I think. You can edit the shaders later on as you wish. So before we have a break, thank you for that, Shitij. Before we have a break, if there are any questions for the character, you can ask them now, because later on we'll be moving on to the architecture. Mike, would you be able to help with Maj's question?
Yeah, just take a break when you want. Break, it's fine.
I think Maj has a question.
Okay.
Thank you, Harun.
Yeah.
Is there a way to screenshot to better show an issue?
Is there a way to screenshot to better show an issue? Can't you just put an image in the chat? There's an image button. Should be. Or you can share your screen at the end. That's another way too. So yeah, either wait until the end, and you can come on camera if you want, or you can, I think, for me at least, there's a image button in the chat. Okay.
We can probably take a 10-15 minute break. And what do you think, Mike?
Not 15. 10 will be good. Yeah.
Yeah. Probably answer Pedro's question a bit before we we stop. During the import part of your FBX, I didn't see you set any nanite option. Is it because you have a low poly nanite model? So nanite is for static meshes that that uh, that are used to populate your scene in a very detailed way. It doesn't work well yet for skeletal meshes. In our case, it's a moving mesh, so we can't do that yet. It also doesn't work well yet with foliage and plain objects wherein it's very thin, because what nanite does, it's the newest technology, one of the newest technologies I think of Unreal, wherein you're able to populate your scene in such a dense way, and it only calculates what you see. Anything you don't see won't be calculated, so it's super fast, you can create a super high fidelity scene with ease. So that's why we didn't use nanite. What's the importance or function of canal alpha in that material? So if you're meaning this, if you're referring to this alpha, so the idea is in this lerp node, you're actually trying to blend two values. Initially, we had orange and teal, and the alpha is trying to tell you which parts are orange and which parts are teal. So what this linear gradient does, if you want to see it right away, check it into the base color, save it, and we can go see here. So what the linear gradient does is there is a black part and there is a white part. And we wanted to use that black and white part as an alpha, or to say where the white parts are, you have orange. Where the black parts, you're going to have teal. Or in the lerp 3 color, the gray is teal and the black is pink. And then you plug that into a base color. So that's the logic of most alpha parameters in linear interpolate. Hope I was able to answer that. All right.
So the other, the thing with about a nanite thing, it's like it's not really for like things that are always moving or dynamic. It's more for like things that are static, say like your environment. But that's also why it's not working great with like foliage and stuff like that. It's like blowing in the wind or something. Okay, you're gonna take should we take 10-minute break?
Yeah, sure. 10 minutes.
Cool. Let's do 10 minutes. Really awesome stuff.
Thank you all for listening to that. We have another part later on. All right. All right. I'm back and ready if you guys are. So let's see. Share. So just to recap, we were able to finish the procedural character and we're now able to walk around with it. So in our program, we just finished the break. We're halfway and we're gonna create the procedural sort of architecture using the same procedural techniques. And what's important to set before we do that is um, in the PDF I sent, there are several steps to create to fix the atmosphere and the environment. Personally, I have this noted down because it's quite a detailed task that it's hard to memorize, especially if you're creating projects again and again. They still sort of get you. So I'll try to dictate them and you can follow along as I go. So first off, you're gonna wanna delete all, let's say all of the basic stuff that came in with the starter content or the base template. So we'll delete that and we'll go on to the lighting. We'll delete all of the lights. Just off. And the floor, we'll keep that there. Documentation arrow, sky sphere blueprint, text render after, all needs to be deleted. Atmospheric fog as well and screen space capture. So you're met with a black scene, so that's ideal. So first off, we're going to create a directional lamp. So after this, you'll learn how to set the atmosphere from scratch. So lights, directional light. This will be your sort of sun. And what you want to do is you have to change it from stationary to movable. And type in atmosphere. Atmosphere. And then you have to click on atmosphere sunlight. So later on, that will take effect when you put the atmosphere. Next, you create a skylight. Light. Skylight. And then again, change it to movable. And turn on real-time capture. So later on, we'll tackle the errors, but it should be this way. It should be giving you this error. And then next is the sky atmosphere. So create visual effects and click on sky atmosphere. And then since we set the directional light as an atmospheric sun earlier, you can now try to move it by pressing Control L. So Control L, hold on Control L and then move your mouse and you can move the sun however you wish. Next, we're going to create an exponential height fog. So create visual effects, exponential height fog. So it's kind of flushed out right now and we want to fix that. So what we're going to do is change the fog interscattering color to black. And the directional interscattering color to black as well. And then type in volumetric fog and then check it. So what that does is you actually now see the fog affecting the light and scattering it around nicely. And then next we go to window and or edit, go to project settings and type in fog. We want to have support atmospheric fog and support sky atmosphere affecting height fog on. It's asking us to restart. You have to restart now. So remember to save selected. Okay, now we're back. So right now you have an even distribution of light. And then next, we want to create a volumetric cloud. So create visual effects, volumetric cloud. And after this, you have now better looking lights, better looking clouds. And next, and finally, we create a post-process volume to create to control the exposure so that it's not too bright in areas, or it's not too dark. It's basically an auto exposure. So we create visual effects, post-process volume. So in the details panel again, go to lens and then exposure, and then turn on minimum and maximum brightness. Set this both to 1. And you see it's not taking effect yet because you actually still need to tick and in infinite extent so that it extends to your whole scene. So check that it actually balances it a bit. So even if you put it too dark, it's still proper lighting. And right now it's a bit flushed out, but I'll leave it to you again to choose what type of lighting you want. So again, Control L to move the sun around if you want. And then at this point, we can pick objects, a starting cliff, let's say, a starting cliff to put your scene in. So go to Quixel Bridge and collections. There are many collections here, but I like using the Iceland collection. Let's look for Iceland. So if you're using Quixel inside Unreal, everything is free. So the way to do that, if you want to import Quixel directly into Unreal, right-click on the content browser and add Quixel content. And this opens up a Quixel bridge that's only for Unreal. The one we opened earlier is for, like this one, is for exporting to other programs such as 3ds Max. That's for later. For this Unreal, let's find an example. Once you've downloaded anything, let's say we have this cliff here, and then you've downloaded, let's say you've downloaded already. Press export. Let's see. It actually appears here in Megascans, 3D assets, and Icelandic cliff. Here. So Control Space again to bring your content browser up. After you exported it from, it's actually this one, exported it from Unreal, click export. Again, it appears here in your content browser automatically, which you can just drag and drop as you wish. So later on, we'd be able to use that. So an important thing to note is you have the back-facing faces. You cannot see them because in Unreal, you have to turn on the two-sided materials for it to appear. But in this case, we wouldn't want the back side to be seen anyway. So delete this first. Let's see where we're at. So in this image, the architectural piece or the building or whatever we created is actually built around this cliff. So I want you to go to Quixel Bridge and find the cliff that suits your liking. So let's say this is in Iceland. Maybe this would be good. Weathered Icelandic lava spire. Ideally, it's a geometry that can hold your mesh, the architectural piece. So let's look at the settings. So the download settings for the model, to get there, you click on this this icon with the sliders, go to download settings, go to models, and then it says all of these options that have different LODs. LODs mean level of detail, and in game development, this is very important because people have different hardware, and if people are using your playing your game but have lower hardware capability, you'd have this LOD system built in, wherein if they click lower resolution or lower graphics, it automatically brings down the level of detail, and that's set for all of your meshes. Whether in this case, it may be fine to just have like a middle resolution mesh to work with. So let's try downloading this one. May take a while. So once that's downloaded, go to 3ds Max. Let's create a new project. So you can leave your character clean. And then let's go ahead and go back to Bridge and click export, see if that works and see if it gets brought to 3ds Max automatically. So exported, let's see here our scene, and here you have it right away. And whatever render you have on, let's say Corona, V-Ray, or just the standard, it will have a material brought in for you automatically as well. So that's pretty neat. So let's just move this here. That's the material that came from Quixel right away. And first off, we want to scale it properly according to how big we want it. So let's create a box as a reference for your character. So people are normally, let's give an average that the person is 1,700 millimeters or 1.7 meters. So that's the height. The width of your shoulders is around 120 millimeters. And the length for your is around 200. You can use that, or you can just import your character. So let's see, import your file, import, can bring in whatever we created earlier. Okay. So click OK. And see, we have a character. The character we created here as a reference to create it. So it's just about the same. So if you weren't able to bring it in, you could just use a box. And we want to scale this. Delete that Arnold properties. We don't need that. We want to scale it to a size that sort of fits what we want. So again, click on R to bring out the scale gizmo and then scale it up. Move it by W, bring it back. So if we're looking at our image, the character is approximately this much and it's big. It's probably a 3 to 4 story building. So let's bring this down. Let's check the size of our box. So probably that would be fine. So for us to create a volume around this cliff, we can start with a primitive. So let's go to create and then standard primitives, create a sphere. If you're bothered with the grids, you can just press G to remove the grid. And then let's say we're gonna have an oval-like or an ellipsoid piece here. I want to start there. And let's go to the modify tab and click on FFT. It's like a box wherein you could just move the control points. So you can have it that way. Bring down this arrow so that you'll be able to select the control points and go to your other viewport. And if you want to bring it lower, select on those control points and then bring it down. And you can play with it however you want. Let's make it thinner a bit. So if you want to have some sort of variation, there's a noise node which you can use, and you just have to input the strength. Let's say this is according to real world measurements. So let's say we want it to move around a bit, maybe 3 meters, because that's, I think, reasonable. 3 meters or 3,000 millimeters. Have the scale go down. Maybe make it bigger to be more drastic. So let's try 10 meters. Maybe that, and then let's see what happens when we go to the modify tab and click a turbo smooth to see that it's actually displaced differently. You can do it this way, or you can go on and have a texture displace it again. So let's try to delete this first and click on the displace tab. And then again, you're gonna wanna uncheck or check use the existing mapping, that's the UV mapping, and do not apply the mapping. And let's try inputting the cellular map that we created earlier with the characters, or you can use any map that you want just to add variation. Or the noise map, let's say. Instance, let's duplicate this because it might be too small. Drag that onto the map. Make this a bit bigger. And then let's see if it works here in the strength. So again, this works with the real world measurements. Maybe let's try 10,000, like 10,000 millimeters again, or 10 meters. Let's place it much. We can have a larger scale so that it's more drastic. Try 200. Increase the displays. Maybe let's try 30,000. Increase the size. 7,000. Maybe 10,000. Let's see. So at least we have a bit of variation. Let's see. 1,000 might be good. So we don't have just a starting sphere of a sphere or just an oval. Let's increase the strength again. Let's see how it works. So this can be our base mesh. You can use any base mesh you want. We're trying to create sort of randomized procedural design. And then, as I discussed earlier, the same procedural techniques with tyFlow. We can use tyFlow here. And then open editor. Again, go to this orange panel wherein you have a VDB, all the VDB operators, birth VDB, and to bring the object to a VDB, to this VDB again, go to object to SDF. And then make sure it's not too dense. Earlier, because we were creating a character, 10 millimeters sounded pretty good. So, but for a larger scale, maybe you'd want it bigger. Let's try first 1,000 or a meter. And then add this. As you see, it's sort of the range we might want. Let's see, we can already turn off our sphere here. And we can work with the maps like earlier, wherein we're using these maps to regulate the volume inside. But maybe let's go back and edit this sphere a bit, because it's looking too high. Turn this off, go to displace this FFD modifier again, bring it down, control points. Probably make it a bit sleeker. And select it and then bring it back down to conform to the cliff again. And then click on displace. So let's turn off our sphere again, turn on our VDB. Let's see there. And then what you want to do is subtract the cliff so that you're creating a volume that actually considers the cliff. So bring in another object to SDF. Since this node was actually adding the sphere, we want to subtract now the cliff. So we'll click on object to SDF, subtract, and then pick on the cliff. So let's see if we move the sphere down to, let's say, show the peak a bit, turn off the sphere. We see that when we turn off the cliff, did it? Actually, we have to make the cliff a volume first for it to consider it. So pause this first, turn off the node. And you see this cliff actually has a hole at the bottom. So if you want to edit it, we're going to convert it to editable poly. Click on 3, like the hotkeys that we mentioned earlier. 3 to click on the border. So you click on the border and then go down to edit borders and press a cap. What this does is it basically closes your borders. So try to select if there are still any borders left. This is a good way to select if you're to check if your model is watertight. So in this case, it's good enough. And then try and turn it on again. Click off the cliff and we see we actually removed the cliff area already. So I think that's good to work with now. So we did try different sort of methods earlier. Let's try to check if those methods still work right now. So with the noise map, let's duplicate it because we use this noise for displacement. Let's duplicate it, so we'll play with this one. And then again, VDB convert so that we can manipulate the volume itself. SDF to density. Make sure your VDB to mesh is set to density as well. And then VDB modify. You have to set that as density as well. Go to minimum, scalar operation, and then text map, wherein we can input a texture or a map that we created in the materials panel. So pick your object, click on the sphere because that's a reference, and then the text map. Go ahead and drag on the noise map onto the text map. In this case, it might be too big, so we can scale it down. Let's try 1,000. Let's play with the high and low a bit to try to play with where the grays are and where the whites are. So let's try to narrow it down a bit. Let's try 0.6 and for low 0.5. Probably a bit fragmented as of the moment. Let's try 500. Or let's also increase the resolution of this voxel density. Let's make it 500. See if that helps. So size maybe let's try 600. And then through that we are able to create sort of minimal density object. And a way I'd like to clean this up is go to your tyFlow node and let's see if we can clean this up using a node called tySelect. So tySelect is a computational way of selecting it as well, much like how you would select it in Houdini, wherein you'd input attributes in Grasshopper as well. So we want to check the elements. And what are we looking for here? We want to delete the smaller areas so that things are cleaned up. So from this gizmo selection list, we try to change the method to, let's say, face area maybe, or maybe volume. Picture. Element size. So let's set it to a minimum surface area or a volume. Let's try to set it to a higher number. So when we set it to a higher number, these smaller volumes are actually non-selected. They're unselected. So you're able to see that these we could actually clean those up now. So after that, you set it to like, let's say 10,000 cubic millimeters of volume. Invert the selection so you're only left with these. Since we still have others that are not tackled, let's raise the minimum level. And you see now it's selected. And then after that, we go to the modified panel and look for delete mesh. So you're able to delete all the smaller ones. See, some are left here, so we can increase it further. See? So we bumped it up to an even higher number to select the others, and then go there and delete mesh. So we're quite in a good spot. And then how we were able to smoothen out the edges. Last time we used a tyRelax node, and this is pretty powerful. If you're using Houdini, this is the same as the delta mesh function. tyRelax. So again, we raise this. Probably try to look at the other options of how to relax it, but you want to relax it until it's a bit manageable. So let's try with or without and with. We'll be able to clean those up more later on. We can go back to tySelect and create an even bigger threshold. Let's see. Maybe those are fine. So you can use that. And the way this was created was there was a positive and negative noise. So if you look at this volume, there is an empty part. What we can do is now invert that empty part, because this empty part was dictated by the noise map, where the blacks are. So we can duplicate this noise map and duplicate your tyFlow as well. tyFlow 2. Input your duplicated noise map. And go to VDB modify and change that noise map. If you see, this has two colors, and these dictate where the volume would be placed. So since we had black for the empty parts and white for the present ones, I'm just gonna want to swap it. So if you see, this is how the texture maps really work. In VDBs, where you want to show or delete some parts. So in this case, we play with this. Let's try to have them in different materials again. And then if you want more space between them, you just have to play with these high and low values. So let's say we want this blue one to have more of a gap between the pink one. We just have to adjust these high and low values. So let's try 0.7 and 0.6. And that's affecting the pink one. Let's try same with if you want them to have a higher gap, or let's bring this lower. 0.4. And you'd have this volume that has some sort of distance between them. So if you change the size on this one, remember to also change it if you want it to fit together nicely. So it sort of remains procedural, even if you had stacks of modifiers on top of them. You're still able to sort of auto clean them. Let's try to make it bigger. So what we're trying to do here is to try to have areas of different material. Let's say this plasma area would be a habitable space, and then the positive volume would be some sort of hallways in between. So when we're trying to play and create with this create forms here, that's what we're considering. I mean, we don't just create a volume and say, let's have this and it looks nice and let's place it on there. Because in games, it's also useful to have them to be able to walk around it. So that's one technique to have the volume. Let's try a bit more exploration. Maybe we want to try out the cellular. So we have two tyFlows, the positive and negative again. Close this one so that you're working with one. And then duplicate the cellular map and increase the size of it to a size that we can actually see. Go back to VDB modify, scroll down to text map, and then drag this into the map. So we see where we actually have more, we have pods in the middle that we can work with. So if you remember, you have this box as a scale, and try to consider when you're creating these pods could be some sort of habitable space or rooms. So hopefully you don't create any pods that are smaller than the person. Let's see if we could tweak the tiling. Maybe that could affect the tiling. This dictates how the map is styled onto your volume. So let's see if we tweak it to, let's say, 2x value. It's going to have a more elongated look. Elongated along the x-axis, but it depends if you want to go with that. But for me, I'm considering a more elongated this way. So let's try 2. And then we have those elongated pods here. So change the view to perspective. Maybe we'll make it a bit bigger so that a little bit more habitable. Let's try 1,200, 300. Maybe have more gaps in between. So let's try mid 5.5 so that there are more gaps in between the pods. And then have the same process for the other side. To have like a positive and negative, you're gonna have the pods here as habitable spaces, and we're gonna create the walls this time. So drag it down again while pressing Shift to duplicate it. And go to your other tyFlow, which we closed earlier, turn it on. And then now just change the mesh, drag down the new one here to the text map. So in this case, it's still using the same. So with the same principles as we had earlier, we're just going to change the color of what we want to show. have the white color empty now. And immediately we now have the borders of the bubbles or the pods. We can tweak this a little bit more. Let's say, let's try 0.6 to have it further away from the pods. Maybe we'll keep it at 0.5 or 0.4. 0.5. So again, we want to consider this map that the gray parts, the black parts are supposed to be unseen. So if we want to have more gaps in between, let's try reducing the spread a bit, because the spread dictates on how the cells actually spread on to one another. Let's try 0.2. And now you see it, it actually has more gaps. So maybe 0.2 is too much, 0.4. I'll be sticking with 0.3 where you still have those volumes. Point 0.4 for the mid. Let's try to have some sort of gap in between them. So maybe bring this up 0.7. 0.8 or 0.9. Looks fine. So let's just check the tessellation. Go to default shading, display selected, and select the edges. So this is another way. Initially, we had the cellular map. Initially, we had the noise, and then we had the cellular map. There is a good-looking map, neat map in 3ds Max called, if you go to Maps, General, Advanced Wood, it actually mimics wood. So let's see what that does. So let's bump this up to a reasonable scale. So again, if you missed that, go to right-click on Maps, General, and then Advanced Wood. And then we go to tyFlow 1, and then do the same procedure as we did before onto the text map. You want to select bump because that's a black and white. And diffuse color is these brown colors. So let's try. It's pretty weird looking. So let's try to increase it a little bit more. Having a bit of holes. Maybe we want it on the y-axis. Basically, I just showed you this so that you'll be able to play with any texture that you want. If you want to create volumes with textures, you can do so. There is one last method that I want to share, which is if you want to, which is to simulate a sort of growth from this. Let's see if you could drive growth or make it expand or make it displace with a texture. So let's try and go back to the noise map because that was a little bit neater. Let's go to noise map and then put it back to the slot, the VDP modify slot. So we have this. Let's try to have the other one, the negative one. So let's go ahead and make it a little bit bigger, maybe twice as big, maybe 1,200 with a smooth flow there. And then let's try to tweak it a bit. So maybe we'd wanna play with the VDB, make it expand a bit according to a texture that we want. So we can try to have another VDB modified here. And then set it to density again. And then time it to continuous so it happens every frame. Let's see what that does. So it's actually expanding now based on the scalars it was set initially. It's expanding and growing. We want to have it expand to a certain texture we set it to. So we want to have a VDB filter, set it to continuous as well. And then have it, the VDB filter actually filters the values or attributes of your VDB based on these settings. So maybe let's go with curvature. And then add in a solver. VDB solver. Let's try to input a wood map. Again, maybe this is too big. And then we want to make it expand based on a texture. So add some scalars to the texture area. So you have to reference the sphere again. And then bump to the map. Let's see what that does. So right now we're just putting other maps on top of each other. Probably multiply. Doesn't work. To filter for dilation so that we're actually calculating that it's getting bigger. Nope. Let's try other methods. Try noise. So let's just turn this display selected off. Let's tweak the noise so that it's bigger and then actually happens, like something at least happens to it. So it's pretty funky at this point. You're actually adding voxels to what you already have existing based on based on whatever parameter you have here. You can have this text map as a noise, you can have it even a little bit bigger. So smaller values mean they're a little bit bigger. So let's see what that did. So it's a little bit funkier. It's getting a little bit funkier. So I'll leave it to you to explore the options here to have different textures react differently to your map. But in our case, we'll go back to for the webinar, we'll go back to our initial noise, which is a little bit simpler because we're gonna run a facade or a particle trail around it, like we did with the character. So let's first delete what we created. And we can go back to the noise. We can tweak the noise again so that we can use it for producing something already. So we're using map 6 for the noise. Maybe make it a little bit smaller. Maybe that's all right to work with. Sync your other noise. And then turn in the other tyFlow. And as you see, we actually still have the cellular here. So all we have to do is put it back in, put back the noise in. So there we have some sort of positive, negative already. We can adjust it, the high and low again, to have more of it there, maybe 0.55. Seems fine to me. And we want to have the same sort of particle trails that initially went around this. So we could actually still have everything procedural at this point and have trails go around it. But just to make things run faster, we're gonna bake whatever we have here into a mesh. So let's turn on the cliff again to see where we're at. The box is here. So you still have it. We're relatively following the same sort of form as we have in the example. And maybe let's add a pathway so that we can actually try and walk up it. So we can create a procedural pathway that goes around this. But to make things quicker and a little bit more intentional, let's draw a pathway. So let's minimize first the tyFlow editor and the material editor. So we wanna maybe have a pathway run around here and then go up and then go spiral until we hit the top. So that when we get to Unreal Engine, we can actually walk inside. Oops. Okay. So maybe we can draw that. So go to the create panel and then the shapes. And then you can start drawing lines around it. So maybe go to the top view, go around, try to draw it around, making sure that it actually kind of goes inside the volume. And then make it go around the cliff until it goes up here. Right now you have a flat spline, so you can just edit it. Turn off the rock. And right now we're just gonna tweak the nodes to make them sort of ramp up the cliff as we want it. Then turn it on and off so that you see what you're still doing. I'm gonna just go around it. Don't make it too steep, or else your character will have a hard time walking into it. Let's just finish up this quick path. Go orbit around it to make sure. Turn on your cliff. Maybe there are some intersections here. Up. Try to have it go around nicely the cliff. So the point of this is we're creating a cliff. We're creating a pathway that we want to have go inside. So let's bring it up a bit so that it actually touches the piece. And then let's check the slope of it. So we do that by clicking the line and then the rock, and then click on isolate so that you just see that and everything else is hidden. So right now we're just playing with the spline to our liking. Okay. And then after we had relatively good angled pathway, you can play with it. We'll have a tyspline measure modifier. And have the radius probably around as big as turn on the box, big enough to fit in. So we can make it, we can squash it a bit, play with these parameters. Oops, too much. So squash is just, but if you want the sweep of it to align to the top, we can go ahead and orient it to the world. Sometimes it doesn't appear properly, so we'll leave it to from spline. Maybe edit this a bit so that it doesn't hit the cliff. And then we can have the character go around and be at this area at the top of the cliff once he goes inside. So what we're going to do is we're going to subtract the path. We're going to subtract the path from the volume as we subtracted from the cliff. So we'll go back to the tyFlow, open the editor. And then if you remember, initially we had a subtract part, which subtracts the cliff. We could easily just add the line, and whatever you do with the pathway, it will subtract it. And then go to the other node and subtract the path as well so that it affects both. So pick on the path, and there you have it going through the cliff or the piece itself. So we can name these first before we move forward. Let's say name this path. And then let's name this as the architecture positive. Copy paste that. And name it negative for the other one. So before we move on, maybe some of you have questions, just feel free to type it in. If none, we'll start creating these pathways that initially, same with the character, went around it. So I'll make it quick so that we have more time to dress things up in Unreal. So we can have a new tyFlow. And then make a VDB. And same with the character procedure, we're going to create a force field around one of them. So let's say, but since these, wait, we can actually just have it reference the other tyFlow directly. So let's try birth VDB, object to SDF, and let's reference the blue one, which is the positive. We're gonna have to cancel that because I forgot to have a bigger density VDB density, so it's calculating those million ones. So don't do that. We forgot to adjust it to become a bigger density, and it is the same density as we used with the character. So probably wait for that a bit. In the meantime, if you guys have questions, feel free to ask. This might crash. We might end up trying to restart this, but hopefully not. maybe we'll go ahead and try to restart it, but first we need to check if it's actually autosave. Well, apologies for that. So it did crash, and fortunately, this will try to save a copy of it. And good thing, even if we never saved it, it actually saved the autosave. So let's try to open it again and see what we can salvage. Yeah, it's true. Worse even with Maya, Pedro. Let's just wait for it a bit. It will open. So if you go to file, hopefully it's here, open recent, and then it's gonna have a recovered, untitled recovered, because we never saved it. Which, we will now. Although it might have auto-saved the mistake that we did with the VDB wherein we set it to then, so maybe close that. End the task. And then open it again and try to open another autosave. I think the good thing about this is the default autosave is every 5 or 10 minutes. So that's true. Luckily, we see in the autosave folder that it backed up several of them, so I think we're in the good. So open. Good thing we have it. And we're back without ever saving it. So now we learned our lesson live and we should save it. So let's name it Metaverse Inception Architecture. Let's get back. So go back, let's get back to opening the editor. Let's bring this Scene Explorer back again so we see everything. See all our items here. Create a new tyFlow. First VDB, and this time a voxel size of maybe 500, just like how we did before. Then let's try referencing it. So let's reference the VDB that we created. So we'll save this again as and the other one negative. Then let's reference the blue one, which is the positive. Okay, thankfully it works. And what we just want to do is to have a force field or a vector field around it. So just like before with the characters, VDB modifying and VDB display so that you'll be able to see the vectors on how they're working. And turn off the mesh. Let's see if we see this. Let's go to tyFlow and then isolate. As of now, we don't see anything. Maybe it's not showing the velocity vectors. So we're just trying to look for the dots. Maybe it won't show because we need the input vectors to be higher, like a 10. VDB display. Won't show yet. So let's see first if we could try to work around it even without it displaying, because initially we wanted to have it set to a noise 3D like we did before. See that? So let's try first by birth. Like before, we set the start and end to 0 and define the particles. How many do we want? 2000. Let's try that. And align it by position object to position it on the blue. So that we saw. So you see now the dots are there, but you want to bind it to the blue area so that it moves around it. So lock the surface, snap the surface, and then friction at 0. And then we want the spline paths to actually see where their trajectories are. And then let's see now if the VDB force actually works. So go ahead and drag on the VDB force here and then click replace and then replace again. And let's see. It might not be working strong enough. So let's set it to curl. And then let's set it to be a little bit stronger. We have to bind it. I forgot to actually pick the object to bind it to the positive. So let's see. Doesn't work yet. Maybe it needs to be more. It's actually moving now. So go ahead on spline path. So what we did is increase the influence to 1000. Go to spline paths and trajectories and create new. So it's going around this. Maybe we want a larger scale. So the way to do that is go ahead and go to VDB modify and curl and have a smaller scale. So if it's a smaller scale, it results in a bigger pattern. So 0.01. 0.001 maybe. And then we actually start seeing some sort of pattern go on. So if we check this, we're kind of close to having. So we went from, just a bit of a recap again, we went to having the cliff imported, and then we have the base mesh, and we subtracted the cliff and the path. So now we're on to creating the facade. So I think at this point we can either still let it stay procedural, or we can bake it, since maybe this would be in a good position already. So let's take the architecture negative and clone it. And then convert to editable poly. That way we can actually turn the positive off already. And then we'll do the same with the negative clone. And then convert to editable poly. So we have two. So we can also turn this off. You can make sure both are off. Actually, before that, we need to also bake the splines because they disappeared. So go to tySplines and go to tools, extract the splines. So you can now have all the functions and processes turned off. So turn this off so that it's not too heavy. Turn this off as well. And you can name this tySplines architecture underscore facade. So let's set this as let's put a tySpline measure. Or actually, let's see first, maybe it's too dense. So like we did before, where we're going to normalize it. Let's see. Let's see the splines. And yes, they are too dense. So we're going to normalize them so that they're not too dense when we import them. Normalize spline on the modify tab. That's right, Diksha. Experimenting correctly when it crashes. So the normalized spline computes all of the splines, so probably will take some time as well to calculate. But the safe thing about it is it has this max knots. So it limits it to 1,000. So in this case, let's try to estimate how long we want the segments to be. So like our old method of creating a sphere and seeing what the distance is. So the radius is 300. Maybe we'd have a good distance to each point at 600. So let's go back to the splines. And then have the segment length at 600. And as of now, it's still calculating. And have the uncheck the max knots so that it calculates it correctly. Hopefully not too long of a wait. And there we have it. And let's create linear segments so that when we're meshing it together, the polygons are exactly our segment length. So it's actually calculating quite a bit because it's heavy because we have a lot of splines and they're long, but this is fine. And then let's try to put in the spline measure again, like before, and have a bigger radius. Maybe let's have it at 50. Then we see it now. And then let's try playing with it a bit, like how we did before, add the squash. And then you see it has some sort of a leaf-like geometry already. And then what we did with the characters, we also checked and curve, and then modified it to be like this. And then symmetrical taper, so you have it like arrows opposite one another. If you want to go further into creating some sort of differentiation with them, multiply radius by length. And then let's say our length threshold is 5,000, invert it. And then somehow you see some of them are thinner than the rest. Let's try. 10,000. Maybe let's set this as 20,000. So you'd see some of them are really thin, some of them are really large. So, and then maybe let's have some sort of rotation so that they're flayed outward. Maybe 90 for the rotation. Maybe have it a bit bigger at 100. So you can play with the parameters up until your liking. And lastly, maybe we tackle the pathway. So you can have the pathway the same way as we had the tyFlow before, this facade. So we can create a new one again, reference that. So I'll just run through this quick because we've done this already. Birth VDB, remember that not to make it too large or too small. And then object to SDF, pick your path. Now you see we already have it there. Turn it off, turn the VDB mesh to off because we don't need that. VDB display to show the vectors, but it's not really updating as fast. And then modify so that we create the fields based on how we like them. So in this case, we set it to noise 3D with a larger scale. So let's see how that works. You can do it again with again birth particles. We want to birth it on the path because we want to have in this image we have a path. We have a path and it has this noise trails around it. And again, set the start and end to 0. Maybe have a total splines of 1,000, for it not to be too much. Position the object to where you want the particles to be. Object bind so that it remains on that object. Pick this and then lock the surface, snap the surface, and then friction at 0 so that your particles slide. Spline paths so that you see the trajectories. And finally, the VDB force, which you set to replace and replace. Let's see if it works. Maybe you have to have it stronger again. Maybe a little bit stronger. And an even smaller scale. So maybe we go with 3. And you see it actually creates your path. So if you're good with that, you can either have it at that or smaller in scale. 0.2, maybe it looks a little bit better. And then turn off your path. So we're creating a sort of path here. Maybe we'll fix it to a standard cylinder so you can actually have space to walk inside, and we're sure to have that space. So go back to path. Remove the squash. Radius probably a 3,000. Then increase the sides so that it actually is not hexagon by 12. So it's more circular. So we can turn that off now. Then we sort of have our different looking path, like how we had here, that we can enter. So we have the facade of the path, and then you can go duplicate the path so that you have a sort of a board to walk on. And instead of having it as a tie-spline measure, we can go use another modifier, which is sweep, and have a bar. And we want to have it sort of walkable. So probably maybe 3 meters. And have it offset so that it's at the bottom. So maybe negative 1,000, maybe it's too low. It's actually hitting that, maybe negative 500. And then turn off the banking so that it's absolutely, you have it there. And we just have to put the test splines here, and we're ready to send it to UE, to Unreal, for the processing of the whole scene. So you can go customize that again if you want, but in this case, we can do with that since we might be running out of time. So before we export it, maybe I just ask for like 5 minutes break so that we can attend to our necessities, if you will. Maybe if you could just type in your questions while I'll attend to a bit some of the necessities if you want coffee or what. So I'll be back just for 5 minutes. So I'm back. So let's export the scene onto Unreal. But before that, let's check if everything have the different materials. So let's just go ahead and duplicate this for the sake of having different ones. Let's have different colors. Just picking them out randomly so we just see a visual cue that they are different. Shift and drag to duplicate. Because we're going to want to set different materials for each. In Unreal. So now they're kind of set. And let's try to send it. So let's try selecting all of the objects, including the rock. So maybe while holding control, just visually select them. So we see 5 objects selected. We have the outer, the inner, the facade. We were missing something. Just select them here. The positive as well. Yeah, that's what we forgot. And let's try and export it. Let's try to export them. So export file, export selected. And then choose the folder wherein you want to send it to. Exports folder, and you want to roll down Unreal Datasmith if you were able to download the plugin correctly. Just type in the questions if you weren't able to. So we'll have the Unreal Datasmith here. Have a file name. Let's say it's architecture. And let's wait for it to export. Probably won't be as important, these items. So let's try going back to Unreal. And then control space again to bring out your content browser and create a different folder just to house all of your architectural items. So let's say have this new folder as, let's say, structures. And a good practice is to have a folder for meshes, textures, materials all separately. So that's what I'll do. Meshes, folder for textures, materials. So let's see if we can import. Let's see. File. So it's at content, import assets, and import datasmith. So let's go up where we saved our Unreal Datasmith, and hopefully it will import it as is. We don't have to save it as an FBX or what. So click on the export and datasmith, and let's have it in the structures folder. So uncheck the lights and the cameras, no animations, just geometry, materials and textures, and import it. So let's see. It's loading it now. It will take quite a bit of time to actually build the textures. But since it didn't really import the textures of the Quixel, maybe we can go ahead on to Bridge, where it's actually connected to Unreal. Maybe let's double check which mesh that was. So weathered Icelandic lava spire. Go to your bridge here. Type in that. You should find it in field. Let's try to look for it here. Type in Icelandic, maybe it would show up. So 3D assets. Do not here. Filter it to just 3D assets. And it's probably this one. So you'd be met with same export settings, but in this case, you don't have to check out most of them. Just check out the quality which you want to import. There's several levels of details that you can download. In this case, there's also nanite, but this might take some time to download. So let's try it at medium quality. Just give me a sec to log in the details, as I think everyone needs to log in their details first before downloading anything. So now we're logged in. Let's download it, medium quality. To make it quick, but you guys can download the nanite version. We can also set the nanite any mesh to be nanite inside Unreal. So it exported it. Let's check if it's here. So it's here, weathered Icelandic lava spire. So what we can do is just go ahead and click this spire and change the static mesh so that we don't have to change any of the location. In this case, it's a bit tilted. So let's just rotate it back to 0. And there we have the actual Quixel mesh ready. Change the light settings so that you'll see everything first. And it's a bit blurry now because we have the exponential height fog at high density. So maybe let's turn that down or turn this off first. so that we'll be able to work with. And let's remove the floor as well. So before we do the shaders, we want to set the landscape actually for this one. We want to create a landscape to actually walk on. So for that, we go to the landscape editing mode, activate landscape editing mode, and create a landscape. It's going to create a default landscape that we can actually sculpt or play with. And let's say let's actually have this all higher so that the pathway is out. So let's move this whole thing. Click on the this actor, which says architecture, which is the name of your file, and just drag everything upward. And then let's go back to the landscape and try editing, like sort of editing your landscape a bit to how you want it. So right away, there's the sculpt, wherein you just set the tool strength here, brush size. Just drag to increase the height, and shift, hold on shift to decrease it. So maybe we just want to have like this cliffs at the side. So let's go ahead and sculpt those. Let's just have a base valley because later on we'll be adding Quixel assets at the side. At least the part where we're walking on, it's a bit undulated. So we're at the sculpt part, we can choose the noise, have the scale a bit smaller. Oops, that's too strong. Maybe flatten these areas so that we have a nice sort of walking area to approach our building. And do that, have a smaller brush. Have it there. So we want our character to start its approach somewhere with a distance, within a distance. So that when you're approaching, it's some sort of drama maybe. So go ahead and click your third person character, place it somewhere a little bit further away, and you can test it again. So the exponential height fog is still open. You still have to edit that. What's good is it works nicely. You can play around with your character, check what you've done, and have it at that. So I'll escape this to go back to editing mode. And let's go ahead and look at what we have in Quixel. So I suggest you download whatever mesh you want. So let's go back to the Iceland collection. go to 3D assets, nature, and then probably have some rocks here. In my case, I'll check for some of my picked ones already. So let's have this cliff right here. Download it. And then export it. Automatically, they'll load in your content browser here. So let me just go ahead and download a few and place a few, and then let's put them on our scene. Maybe we could have this as well. And some rocks at the floor, maybe, so that they look better. It's up to you really what you want to put, but we're just going to show the workflow on how simple they are, how simple the method is. So let's check what's here. So we have the one cliff here, a spire, have this here. Let's add this other cliff and another one. So let's start placing the cliffs that we want. So make sure you're on select editing mode, not on landscape mode. And as Pedro mentioned nanite earlier, let's turn this into nanite so we can create we can scatter them as much as we want without having any problems. I think because this has really high capacity. So let's enable nanite for this jagged cliff. And right click and enable this as well for this one. Have it same here. Try to enable it for all of your assets. So this is how it looks with nanite. I think it's relatively the same. It's just that if it's not seen, all of the polygons that are not seen will not be calculated. So it's super efficient. So let's start placing cliffs here and there. So put it here. Let's see. And then if you want to duplicate them and move them easily, I think it's Control W to duplicate. So you see duplicate it here. Might want to have another cliff here. Control W. Basically, this is up to your taste. Let's have the spire that we had earlier. Maybe let's have them here and there. You can actually just place them one on top of the other because they're nanite. They won't be computed when they're not seen. So that's what's good about it. Try to adjust the lighting of it. so that we see the shadows of things. So just go ahead and populate this cliff over here, enlarge it. Basically just play with it however you see fit. And you can just even randomly place these cliffs, and they're gonna look good because they're made in Quixel. Let's speed up the camera a bit so that when we're moving, it's not too sluggish. This one's another cliff that I placed in. Might look good, might not. Depends on you. You see, it's not actually placing the shadows on that side because it won't show. Maybe just duplicate it and have it at the other side so you're actually having shadows pocket, or I think that works somehow. So when you're creating these shots, I think it only, most of the time it matters only if you see it or not. Like the back, for example, you won't be shooting any scene at the back, so maybe just on this side. Cover this up area. And then basically just before we put any material here, we're just gonna scatter as much Quixel to our lighting as we can. So make sure you have some of the assets that are for the ground. Let's say these rock assemblies, they work well for like populating them on the floor. Sometimes you don't even need to put a material on the landscape itself if you have enough of these. So I think that's what we'll do. So export this rock plates, this rock assembly, and this other one. So they're all loaded onto your scene already. Let's try to just place them. Maybe we can use the Quixel instead of having them pop out, the landscape pop out like this. Maybe we just use the Quixel to have the volume up and down. Let's try flattening it. Enlarge the brush. Maybe sculpt to go down a bit. And then go back to select mode and start enlarge this. So let's not have it click to each angle so we have more adjustment. So I'm just gonna go ahead and populate the scene this way. This is what's good about Unreal. You can have a really high number of bodies without having any problem. So let's try to put the texture on the landscape and see how it works with what we've created. If we still need more pixel assets. So same way how you downloaded the Kit 3D assets, go ahead onto Quixel again. And maybe look in the same collection. And then look at surfaces. Maybe we'd want this rough texture. Rocky ground, yeah. Go ahead and download that. Let's say we already have a ground texture. Let's try. See if it's downloaded yet. Let's try this. So it's gonna appear here on mossy ground. And just select your landscape and select your material actually first. Go to your landscape and then use the material. As you see, it's quite tiled up, pretty small tiling. The way we could fix that is go back to the material itself and double click the material. So it brings you up to this editor. You check tiling and offset, and then maybe turn this into a smaller number. Let's see. So see, it's a bit more workable in this way. So maybe with that, let's start populating it a bit more, and then we'll get to the shaders. And again, you can stack up as much as you want, as long as they're nanite. Let's check. Enable. Once in a while, save all of your assets, because you never know. Let's go ahead and test that. So in your own time, you may want to populate it to your liking. But if you want them to be colliders because they're actually syncing, go to Browse Asset, double click that, let's say this area, this part, and then you want to go to collision and then auto convex collision. Bring up the hull count to a fair amount and then apply that. What that's going to do is that's going to set a collision object for it so that you don't fall into it. So remember that, apply and save. Go to the map, play again. Let's check. And you're actually stepping over the rock solid. You're able to fix it a bit. So you can populate the scene as much as you want. Put some plants, some other objects, put some water material. Play with the landscape a bit. In the meantime, we'll get to the shaders. So we can take a look at this and see that there's some sort of plasma effect, and I'll show you how to create a shader that makes it move. So go to your material browser, go to structures because that's where our mesh is. Go to materials and create a new material. Let's name it M plasma. Remember not to set first like your architectural piece or something that has a moving texture or a transmissive texture or a translucent texture. Don't set it to nanite because that doesn't work well with it. As much as possible, use nanite on the pixel ones first because those are the ones that are really high density that you need to work with. So let's try the plasma shader. And what you want to do is import a texture, and we can go ahead and I've had this liquid texture that I can send over to the chat if you want. If not, you can look for any seamless liquid texture on Google. So, everyone, yes. So I've sent, and then you have to open your content browser, go to textures, go back to your folder and drag it in as a texture. And there we have it. And let's see how this reacts. Let's drag it in as a texture sample and then plug it into base color. And then go to your map. Go click on architecture, positive, browse to asset. Double click it so you can actually edit it. And see here you have one material that you can put. Go to the materials and plasma, set it to that. Save this so that you'll be able to see. And there we have some sort of rough texturing around it, which is not really ideal. So let's see how we can work around that. Maybe let's go back to 3ds Max and set an auto UV for it so that it wraps around nicely. So that's only important for these two because that's where you apply your materials. Go ahead and go to the modified panel and click UVW map is basically an automatic UV, because if you've seen here, the UVs are really messed up, and the UVs are sort of squares wherein it sets which polygons are facing which part of the texture. So let's do it automatically, so it's not too heavy and won't take too much. So what I'd like to do is click shrink wrap sort of texture. Let's check how that will respond. So click M again to bring up your materials panel. And let's create a material. Or let's rather use this. And then let's search for checker. Maybe we can have this to check. I basically use this to check if it's working. Might be too small. Let's try to check in other ways. Show material preview. Actually, it was supposed to be for this one, for the blue material. So see, it's probably gonna map it out that way. Let's increase the tiling so we'll be able to check. It will map it out based on a shrink wrap, so it's gonna look like that. So let's see how that works out. Let's do the same for the other mesh. Let's just copy it. Let's just copy the UV map onto this one. And then export these two to bring back to Unreal. You can export them as Datasmith again. Another name, Datasmith as well. And let's try to bring it back. So back to where we had our mesh, we had it in architecture and geometry, and go again to content and Datasmith, import assets there, and import the next batch that you created. Let's see how it reads it. So because you've set the lights already, it's going to import a random, a default exposure setting from Max, which you're going to want to delete right away. It's named global exposure. It's here. If not, you just search it. Global exposure, click on it and delete it. That right away will bring back your settings. So let's delete our old parts of the model. This is the positive and the negative. Let's bring this back in. Let's try going to the negative and then browse to asset. Double click to bring it up again. And the texture or the material that we created earlier, let's use that, and it works a little bit better. So we can go back to editing the material. So Let's put in a texture coordinate. And in the texture coordinate, we'd be able to set the tiling. So how many, like if it was too small, we can tile it a bit more. Let's save that and see how it reacts. So it's reacting a little bit better here. If you want to choose another mapping method, you could, but I'll show you how to animate it a bit, that we're actually going to plug it into the emissive color. So let's type in the panner node, and input the coordinate here. There's a time input node that you have to put. It's just present time and then drag it in there, time here. Maybe have a period there and plug it into the UV, and let's see how that reacts. Let's have the speed at, let's say, 1 at X. Let's see how that moves. Doesn't. Too fast. Let's have it pan left to right. So let's have it 0 at Y and maybe 0.1 at the speed. So let's see how that reacts to our. Immediately you have something moving like this. It's kind of funky, but if you like it, go with it. If you want to change the texture, that's fine as well. So let's try to input it into the emissive map and change the color. So let's go back to our shader. And whatever input we have here, it's black and white. What we want to do is multiply it to a color of our choice. So let's say we'll have it green or teal. Have it multiply here. Check how it looks. And we change the color based on the black and white map that we have. And then again, actually we can change it a little bit green. Multiply it again as we did with the emissive before. Let's give it a value of left click 1 to bring out the values or the scalar vector. And then let's set it at 15 first. And then we can have that as an emissive color. Maybe that's too strong. And then let's check. Maybe the scale could be improved with the tiling, but I'll leave that to you later on. So let's go next to this facade that we wanted to tackle. We already created that gradient material before, so we'll probably take it from the character and modify it from there. So let's check the character, bring it up a bit, check if things are working properly. Yes, they are. if you want to have different emissive materials for those, let's go back to our mannequin where we created the character, and then materials. We can easily just duplicate it and go in the material itself and change the color. Let's have a teal one. And then while it's selected, go to your map, pick one of the, let's say this path splines, and then browse the asset so that it opens up in your content browser. Open it up, and then just click on use the material, whatever it was. But since it was unselected, again, go back to character, the material here, and then use it. And then you have it as an emissive material here. And now we can, let's say, duplicate this body outer. So right click and duplicate it. And then let's go play with the colors. And this is entirely up to you. I'm just gonna play around with it, but let's try to have it at that. Maybe it will look good. Let's save that. And then go back to your map, select the facade, browse the asset, and double click to open it up. Start closing some of these. Plasma, we're kind of done with that. The rock, we're a bit done. The facade. So let's go back to the materials where we set it initially, body outer, and use it. I think that looks fine. Let's go save it. Go back to the map, and we're set. For the last few materials, you can go ahead check your Quixel with whatever you wish. I think with the basics of the creation of the materials, we're kind of set with that. Let's try using Quixel. Let's look for a metal material. Let's try this surface. This rusty metal. Let's download that. Or actually, I was downloading from the wrong one. Let's try the bridge from the inbuilt into Unreal. Let's see that. Let's type in metal again from the collections. Surfaces. And let's go ahead and download this one. So let's wait for it to download and have the same procedure as we did before. So export it. It's gonna appear right away here in our mega scans. Let's look for it, just look for it. As surfaces and rusty metal. You click on it, and then there is a material attribute that you can place it on here. Go to maybe just click on it or search for it in your outliner, and then have this material selected, and then click use. Again, if you would want to play with the scale, just double click that and then click tiling offset, and then maybe have it at 3. And let's see how that reacts. Maybe a bit smaller scale. So C10. I think that's fine. It's entirely up to you what you want the material to be. For this one, let's try a gypsum material or whatever you have. Let's try this gypsum tile. Click that. Remember to click your material and then just use it. And then play with the scale to however you wish. So again, a tiling, maybe tile it at 10. And it's up to you how you want to texture your scene. So for the final part, let's try setting the camera so that you could render this. First, let's try to have, I'll turn off my video so that it performs better. So if you remember, we initially had this exponential height fog. Let's modify this so that it looks better for our scene. So what I usually like doing is editing the sun itself to be weaker and have sort of a weaker sunlight. So let's click on directional light, reduce the intensity to about 0.2, let's say 2 maybe, and have some light color in there. And if you notice, some areas are beginning to get darker. The way to mitigate that is look for the skylight and then increase the scale of that. Let's say let's try 3. So you sort of have this eerie look to your scene, and it's really again up to you how you want to play with your scene, how you want your skylight to be, what color you want it to be. So I think with that, you can at least attempt to render this. So if we want a scene at this point, we want it to look like that. Let's start populating the scene. So if you want your character to be placed there, go ahead to your character mesh area, part of the folder, drag it in. Have this guy look at your piece, and then insert an animation asset. You can either do the running one or the walking one. In this case, you can do the walking animation. And then create a cinecamera actor. So what it does is you're able to create a character with cinematic lens controls. So we can just easily rotate this. So when you select it, it actually shows in this area the view. So I'm going to change the controls, the gizmo so that it can rotate from the world to your object. So if I click this gizmo to local object, we can rotate it based on how it's pointed. And for bigger architectural scenes, I'd like to use a wide angle view. So the way to do that is go to lens and probably click the 12mm prime, because this is based off of real real life camera lenses and settings, and the smaller the millimeter, the wider it is. So let's try clicking that. And maybe at this point it can look good, or it can look better. We can populate the scene better, but let's try to have it at that. Let's try to have your scene and so we can play with the color of the exponential height fog interscattering. Let's see. Fog interscattering color, it's set at black. You can set it to an eerie blue color if you want. The atmosphere skylight, we can tweak that as well. See, it's changing quite a bit. It looks like a sort of a moonlight look. Sky atmosphere. Let's reduce that a bit. Probably a bit too funny looking. So let's go back and edit our light color to be a little bit stronger. So let's check our camera. Again, you could play with the settings that you want with the width. You can have it focus manually, or what I like to do is, let's say you want to focus it on the character, you can easily check this, draw the bug focus plane so that you see where it's actually focusing. And on this manual focus distance, you can drag it to focus on your character. Either that, or you can track it. You can have it track to focus, and it can track this base character to UE. You can have the camera track to that. And so look for it. Click on that, and it's automatically focusing on that. So a few minutes to go. Let's just set the settings for, remember to uncheck this. Let's just set the settings for the rendering. So in cinematics, for you to be able to create a scene, you're not yet done with creating an actor. You have to create a sequence, add the level sequence, save it anywhere where your folder is. Let's say perspective _1, save that. And then what you want to do is go and drag your cinema actor to the sequencer. So you see here, you immediately see the shots. In our case, we'll only be rendering stills for now. So let's go ahead and try that. We have to save the sequencer first, and then go to Window, and let's look for cinematics and the movie render queue. If you remember, this was a plugin that we enabled at the start. So this is how the interface looks like. You have to go click on the drop down, and it will select whatever sequence you picked. So let's say this. And then to configure the settings, go click on settings here. And then these are the default settings. Click on output wherever you want to save it. And let's try to save it to the drafts. So let's check if you wanna, you can actually make it higher at 3840, let's say at 2160, the 4K resolution. Accept that, and let's see how it works. Render local. Actually, it's forgot to set it to just render to one frame. Automatically, it will render to your whole timeline. We can set that. We can discuss the rendering of the whole animation on another time, but this in this case, we're just gonna handle one frame. So let's fix the output so that it only outputs one frame. Use custom frame rate, 12 frames per second. Frame count, handle frame count at say what, let's see, custom playback range so that you can set when you want to start. So let's start at 0 and then end at let's say 2. Let's see if that works. Render local. See, right now it's trying to render 2 frames. It's supposed to be relatively fast when it warms up. Like in this case, it rendered 1 frame probably in less than a second. So imagine if you had an animation, it would render it super quick, not even, it's probably like 1 minute, 2 minutes. So let's check if it's saved in our folder. So this is the perspective. It rendered 2 frames relatively instantly. And this is what we have as of the moment. You can make it prettier in your own time if you want, but ideally we wanted to teach as much as we could and give you the tools to work with for as much as you want as well. And the techniques, let's say the shaders and the placement of the quixel, you can add as much. Plants, water, you can tweak your character, tweak the view. You can actually put an animation on your character, let's say this one. But you can render this later on. Go ahead and click your character, drag it here. And let's click on an animation. And then let's say, let's try a walk sequence. Let's see if it works. It's actually walking here. So what you could do is have it walk to a certain location. Let's say have the transforms here, location. Have a keyframe here and then scrub to the last part and then have a custom location to your liking. You can move it here or you can move it in the transform area. Let's try to have it here. So let's see, it's actually walking now. So it's up to you to frame or be creative with your scene. It's important that the tools were given and the basics were discussed. Yeah, thank you, Walter. Like I think we can move on to like if there are any more questions. I think we're close. We're nearing the limit. Mike? Thank you, Ali. You just appeared now. Ali, by the way, Muhammad Kamar is my partner in the Masters. Pedro is also a classmate. Super
Walter.
a cat. Yeah, Mike.
No, I was just saying, and Walter.
Yeah, and Walter too. And Shitij and Diksha. Basically, they attended to support me, I think. I don't know. But thanks for that. Very touching.
Are you still teaching,
Uh,
or are
I'm-
you done?
yes, it's done. Basically, we've created the render already.
Okay,
We can, I think we can close.
cool. Let's see. Unreal just crashed. Yeah, that's gotta get on that save button.
Yeah, at least you have to save the assets. You don't have to save the file itself. At least that's what's good with it.
Yeah. So does anyone have any questions they want to ask on the camera? And also, Majid, did you still want to come on the camera and show us what your issue was? If so, just click the raise hand button. If anyone wants to come on camera and talk or something. I'm not sure if you can share your screen. Well, not really sure what we can do for you then. But it's okay. I think just go through the recording. It should work. I don't see why it wouldn't work. Yeah, or you can yeah. I mean, you can reach out to us too. Maybe we can help you if you figure out. Anyone else? Does anyone else feel like coming?
There are some, I think, on the chat.
Yeah. Does anyone
Uh,
else feel like coming on camera? Well, or answer questions here, but if anyone does feel like coming on camera or voice, just click the raise hand button. So anyway, Pedro is asking, is there a way to fix the UV mapping of a model inside Unreal?
So for the UV itself, I'm not sure if the modeling tab has, but how we actually fix it is we go on to the materials. Let's open on the material tab. Let's exit this. There are ways to manipulate how the UV is formed or how the UV is adjusted. You can have it like a world space coordinate, world space aligned screen coordinate where the UV is stuck to your screen, or like it's like a camera based. You can have an object aligned vertical plane and plug that into your UV. But for the question being that to be able to tweak it like how you do it in Maya, Houdini, or 3ds Max, I haven't found out a way to do that yet. Mhm. For the specs, how about Prashant? I think system specifications. I think what the Unreal really benefits from is a graphics card with a better VRAM. I think Mike, you can speak for that. High VRAM.
Yeah, I mean, always the better you can get, like the better, obviously. But definitely, lots like, I mean, I'm using RTX 3090s. You won't really have a problem with that. What did you say you're using a lot?
Right now I'm using a 3080, but when we were creating the Unreal project in um, chapter 4, me and Ali, Muhammad Kamar here, were using the same sort of computer specs, and we only had a 1060 on our laptop, and it didn't die. So I
Yeah, it's
think we
pretty
can.
good. Unreal. But definitely 30 series cards. Like they're they're really good for this kind of stuff. Also, like in the masters, a lot of people are using like render farms too.
Mhm.
I know you guys were using it at some point.
A lot.
Yeah, so they're using a lot too. So that's another thing too. Like,
Mhm.
and they're not so expensive render farms. Really. Like,
That's true.
if you think about the time it saves you, because if you use a render farm, you could use like 4 3090s and finish all your work in like a few minutes versus hours and hours. So that's another thing. Like a lot of the students in the masters, I'd say like half the students at some point are using like render farms like towards the end.
Yeah.
But I think you guys were the first ones doing it, and then everyone else was like wanting to save time too.
Yeah, we had to make do with our laptops. It's really difficult. We had to find a way. Mhm.
So yeah, render farms are definitely a really good option as well.
Yeah.
Quattro. Well, what Quattro? I mean, just because it's Quattro doesn't mean it's good.
True.
Good enough.
Mhm.
P300. I don't know what that is, but I mean, newer Quadro is what, like A5000. I'm not so familiar with Quadro cards, but I think like A5000 is the highest that's in laptops, and A6000 is the highest in desktops. I think A6000 is pretty comparable to the 3090. I was actually looking online. It has more CUDA cores, so that the Quattros are good for like really good for like deep learning and machine learning, but actually the RTXs are performing a lot better in rendering. So I found that interesting. There was like a tense with a bunch of different softwares, and the RTX was always beating the Quattro in rendering, but the Quattro was like by far winning in like deep learning, machine learning, these kind of processes, which require a lot of CUDA cores. So also depends like what you're doing. In this case, like you would want rendering. I mean, we're not doing machine learning, so. But I don't know if P3000 is good. It sounds older because I know they're called like A now. Yeah, I mean, you can just see on the website about recording, like information's there. Uh, will the files later recording? Are you sharing any of these files? I don't remember.
I can.
Yeah.
I can, but the a base Unreal project file is about 600 MB when you create it.
Yeah.
So I can create the GitHub wherein you can actually look. I'll
You
try
can
to
send it to
open it up
me.
now.
I have no limit in space. I can send it to them if you
All
want to
right.
send it to me. Yeah, just
All right.
package whatever you can and send it to me, and I'll send it to them.
All right.
But yeah, be advised, it won't be a small file.
Yeah.
Yeah. Dun, dun, dun. Cool. Well, I think that's it. Great job, Alab. That was awesome. And
Thank you.
thank you everyone who stuck around. And yeah, as usual, you'll get recording and all that stuff after email when it's ready. That's that. So for now, until Until next time. See everyone. See you, Alab.
Thanks, everyone.
If you have any
Thanks,
last
Mike.
words.
Last words. Thank you for the continuous support to my classmates and from you. Look at that.
Cool. Oh,
Oleg as well.
stayed here. Yeah.
Oleg as well. Didn't expect
Cool.
that.
Yeah. All right, everyone.
Right.
See you. I'm gonna end now.
See you. Thank you.
Bye.